very good morning to one and all. That was the journey of JVM from 2001 till date. I, Miss Savita Kumari, on behalf of Department of Chemistry of JVM's Degree College, take immense pleasure to welcome each one of you for the two-day virtual international conference on multifunctional advanced materials 2021, that is VICMAM 2021. It has been our college ritual to start all auspicious occasions by offering prayer to Ma Saraswati, goddess of knowledge, along with lighting of lamp. So, I request Mrs. Janavi Shirsagar ma'am and Mrs. Archana Sanap ma'am to recite our college prayer. Also, I request all our honorable management members and respected principal ma'am to light the lamp. May the divine power blesses us all.
Asato ma sadgamaya tamaso ma jyotirgamaya mrityorma amrutam gamaya. Om Sahana Bhavatu Sahano Bhunaktu Sahaviryam Karvavahai Tejasvina Vaditamastu Ma Vidvishavahai. Om Shanti Shanti Shanti.
Thank you all for doing the honors. I'd like to quote John Quincy Adams: if your actions inspire others to dream more, learn more, do more, and become more, you are a leader. And I take immense pleasure and pride in knowing such a person who embodies these impeccable qualities, the epitome of strength and influence. It is none other than our beloved principal, Dr. Leena Sarkar. I cordially invite you, ma'am, to deliver the welcome address. Over to you, ma'am.
Thank you, Savita, for your kind words. Good morning, everyone. I am extremely proud and delighted to welcome you all to the virtual international conference on multifunctional advanced materials, VICMAM 2021, organized by Department of Chemistry of JVM's Degree College in collaboration with Association of Chemistry Teachers. I would like to thank our President, Shri M.S. Bhum Reddy, Vice President, Shri V.N. Hegde, General Secretary, Shri V.K. Honnur, Joint General Secretary and Treasurer, Shri K. Deshpande, and all other management members for their constant encouragement and support, which made this conference possible. JVM Trust was established in the year 1974 with only few students and has grown exponentially to a sizable number of more than 10,000 students in Kalwa and Airoli campuses together. All thanks to the visionaries who started the trust selflessly to promote good quality education to the population of then rural area of Airoli and its adjacent areas. The trust upholds certain values and principles which cater to the development of area and nation's development at large. The encouragement we get from management of the institution defines their dedication to the vision and motto, that is, to make the institution a center of excellence and a place of quality education. Unprecedented events within last 18 months have stalled the interactions face-to-face, but we overcame those obstacles and adapted ourselves and continued to move on using virtual mode of communication. Material is the basis of all technological innovations. Keeping this in mind, this year's theme was decided as Multifunctional Advanced Materials. The aim of this international conference is to integrate fundamental research, applied research, and interdisciplinary activities concerning multifunctional materials for the development of sustainable technologies. I'm sure the eminent speakers of today are going to open up a plethora of knowledge in front of you. We are truly indebted to all the renowned speakers who have joined us nationally and internationally in our endeavors to achieve our feat. It is a matter of great honor for me to welcome our chief guest for this conference, Professor Dr. P. Ramasamy, FRSC and recipient of Best Mauritian Scientist Award 2016. I feel honored to welcome all the other dignitaries, Professor Dr. Rameshwar Adhikari, former Executive Director, Recast, Tribhuvan University, Kathmandu, Nepal, Professor Dr. Thinakaran Narayanan, Higher National Youth Skill Institute of Sepang, Malaysia, Professor Dr. A.H. Mijinyawa, Sharda University, Noida, Professor Dr. W.B. Gurnule, Kamla Nehru Mahavidyalaya, Nagpur, Professor M. Swaminathan, Nanomaterials Laboratory, International Research Center, Department of Chemistry, Krishna Coil, Dr. G. M. Naziruddin, Retired Principal, Pune College of Arts, Science and Commerce, and Professor Emeritus, Abida Inamdar College, Pune. I heartily welcome you all to the conference to share the profound knowledge you have with the participants. I truly appreciate your high degree of commitment in imparting your knowledge here. I welcome the advisory committee who have done the hand-holding for the fruition of such a conference. Professor Brijesh Pare, President, ACT, Head Department of Chemistry, Mother Science College, Ujjain, MP. Professor Dr. D.V. Prabhu, General Secretary, ACT, Wilson College, Mumbai. Dr. Hemant Pandey, Vice President, ACT, West Zone, Mumbai. Professor A.S. Aswar, Member, ACT, Amravati University, Amravati. Professor Dr. W.B. Gurnule, Secretary, West Zone, ACT, Kamla Nehru Mahavidyalaya, Nagpur. My special thanks goes to Professor Gurnule for his constant help and support to realize this event. I welcome all the participants who are eagerly waiting for the attainment of knowledge and information. I am extremely delighted to see such an overwhelming response for this conference. We have delegates from different parts of India and abroad. Thank you all for believing in us. I once again thank all the management members who graced the occasion and blessed us. Thank you all once again and a very warm welcome to all of you. Looking forward for enriching and fruitful sessions. Thank you. Jai Hind. I now request Professor Savita to take over. Over to you, Savita.
Thank you, ma'am. Now I request extremely talented, efficient, diligent, and hardworking convener of this international conference, my dear colleague, Mrs. Harshada Niju, to speak about the conference. Over to you, Harshada, ma'am.
A very good morning to all. I, Mrs. Harshada Niju, convener of the Virtual International Conference on Multifunctional Advanced Materials 2021, on behalf of Department of Chemistry, JVM Degree College, is extremely delighted and obliged to organize this virtual international conference in collaboration with the Association of Chemistry Teachers. As we all know, new material solutions are being actively developed to cope with the increasing demand by the humans for more efficient mobility as structural energy storage systems to promote better lifestyles and improve healthcare by monitoring and remodeling according to our personal well-being, to act as intelligent system for active sensing and self-diagnosis to morph and adapt in response to the local environment, and to improve product sustainability from cradle to grave via new assembly and disassembly processes. These materials are designated as multifunctional, and they're designed to perform multiple responsibilities through prudent combinations of different functional capabilities. Multifunctional materials are enabling and accelerating the development and manufacture of the products of the future. The aim of this conference is to enlighten all of us about the multifunctional materials and their potential for driving technological innovation. We at JVMs, with the support of our honorable management members and respected principal man, have always strived to promote research by organizing seminars, national and international conferences every year. In the month of February of this year, we had organized an international conference on emerging novel trends in science for human welfare 2021, which was a grand success. And now, with this conference, we aim to provide a platform to young researchers to present their research work and interact with the eminent scientists. This will be helpful to them to uncover new career opportunities in the newest technologies of multifunctional advanced materials. I would like to convey my gratitude to the eminent speakers of this international conference for accepting our invitation and giving their valuable time for the conference. We're happy to receive a tremendous response from all over India of around 4,000 participation and nearly 100 oral poster presentations and paper publications. Thank you all. We wish you to have a great time learning from our eminent speakers. I would like to wish all the best luck to the presenters of both the days for their presentations. Happy learning. Thank you.
Thank you, ma'am. Now we come to the formal inauguration of VICMAM 2021 virtually. I request all the respected dignitaries to officially declare the International Conference on Multifunctional Advanced Materials 2021 open. A very heartfelt thank you to all the respected dignitaries for doing the honors. We are very honored to have eminent scientists and personalities present amongst us to grace this occasion. We would like to felicitate all of them with memento as token of appreciation and love. To begin with, we would like to felicitate today's honorable chief guest, Professor Dr. Ponnadurai Ramasamy. Respected eminent speakers for today's session, Professor Dr. Rameshwar Adhikari, Professor Dr. Dinakaran Narayanan, Professor Dr. A.H. Mijinyawa. We would also like to felicitate eminent speakers of Day 2, that is 10th August 2021 as well. Professor M. Swaminathan, Dr. G. M. Naziruddin. We would also like to felicitate eminent speaker and advisory committee member, Professor Dr. W. B. Gurnule. We would also like to felicitate other advisory committee members, Professor Brijesh Pare, Professor D. V. Prabhu, Dr. Hemant Pandey, and Professor A. S. Aswar. I once again, on behalf of JBM's College, wholeheartedly welcome you all for the VICMAM 2021 2021. Now, I request Dr. D.V. Prabhu sir, former head and adjunct professor, Wilson College, and founder general secretary of Association of Chemistry Teachers, to give inaugural speech. Over to you, Prabhu sir.
Thank you, madam. Dear Principal Dr. Leena Sarkar, Professor Vasudev Gurnule, Professor Brijesh Pare, our President, all the eminent speakers, participants, ladies and gentlemen. On behalf of the Association of Chemistry Teachers of India, I would like to extend a very warm welcome to all of you to this virtual international conference on multifunctional advanced materials organized by Gyan Vikas Mandal's Degree College, Airoli. I would like to congratulate the principal, Professor Leena Sarkar, and all the chemistry colleagues for planning and organizing this international conference. It is heartening to know that several eminent speakers will be presenting their work. Our friends, Professor Ponnadurai Ramaswamy from the University of Mauritius, Professor Rameshwar Adhikari, Tribhuvan University, Nepal, and our very own Professor M. Swaminathan. They will speak on some of the frontier areas of materials chemistry, nanomaterials, nanocomposites, green synthesis, then recycling, structure property correlations, so on and so forth. Today, if there are any new areas, they are material science and biological chemistry. And our traditional branches like physical, inorganic, organic, analytical are slowly merging into these two areas, materials and biological chemistry. The Association of Chemistry Teachers, which started way back in 2000, is celebrating 20 years of its dedicated work and is the national registered body of chemistry educators of India. And since its inception, it has been promoting excellence in chemistry education through its various activities, national and international chemistry conferences, National Convention of Chemistry Teachers, training workshops for teachers, students, and industry people, chemistry competitions for school and college students, and concept tests for the BSc students. This is possibly the only test for BSc students in our country. It was conceptualized by ACT with the help of Homi Bhabha Center for Science Education, Mumbai. Since the early years, we have now diversified into new activities like a research convention, workshop for designing quality questions, orientation workshop for competitive examinations, and since last year, we have had a very successful international webinar on role of women in science. And we would like to continue these activities as the flagship programs of ACT. The association is also actively involved in the Indian national and international chemistry Olympiads. And many of our members are actively participating in the different stages of the Olympiad program. ACT also lends academic support to a peer-reviewed chemistry journal, which is called GB Globalized Research Journal of Chemistry, which is abstracted and indexed in Chemical Abstracts CAS of USA. And every year, we honor the outstanding chemistry teachers of our country by presenting them awards. And also, we would like to felicitate the retired teachers by giving them Lifetime Achievement Awards. We have a large network of active members throughout India and also abroad. And it is a matter of pride that the leading chemical scientists of India are honorary members and sources of inspiration to us. Mention must be made of Bharat Ratna Professor C.N.R. Rao, then Professor Mashelkar, former chief of the UGC of the DAE, and of course, many other eminent people who have been invited to become honorary members. I would like to wish the conference great success, but I would like to thank very profusely our colleague Professor Vasudev Gurnule for taking a leading role in organizing this international conference. I would like to wish all the participants fruitful interactions over the next 2 days. You are lucky that you are going to listen to some very eminent people from India and abroad and make the most of this opportunity. Best of luck. Thank you.
Thank you so much, sir, for enlightening us with your views. Now, I request Professor Dr. Brijesh Pare, Madhav Science Postgraduate College, Ujjain, and President of ACT, to give presidential address. Over to you, Pare, sir.
Yeah, thank you very much. And I'm audible?
Yes, sir.
Yeah. So it was really a pleasure listening, Professor Prabhu. And very good morning to all of you. It's a really a great occasion. And I congratulate the college, JVM College, Degree College, Airoli, for having organized this wonderful conference, an international conference. And that too, on a multifunctional advanced materials. So once again, Dr. Leena Sarkar, the principal and the chairperson of the program, Professor D.V. Prabhu, our general secretary of SET, Professor Gurunale, who is so instrumental in organizing various programs and particularly the international conferences. For the last, almost 18 and 20 months, globally we are facing a pandemic. And earlier, I was thinking, 100 years back, when these virtual platforms like Zoom and Google Meet and when not available, it was something very, very difficult to have all meaningful interactions, even during the pandemic. And now we are lucky to have these virtual platforms. And although we are not moving out much, despite, a lot of important deliberations and things are happening. So I really congratulate once again Professor Gurunale for having taken such initiatives. A good battery of speakers, we are going to speak and deliberate upon the multifunctional materials, and they really multifunctional materials play a critical role to enable and achieve renewable and sustainable energy pathways of the future. So what could be more important, in today's the world, when we are talking about the materials, those who help, in sustainable energy pathways. What I was thinking, like the flexible, the mechanical and electrical sensing devices, we have that demonstrated great potential in a wide range of applications, like the displays we have, then robotics, then in vitro diagnostics and advanced therapies and energy harvesting. So multifunctional materials are really a most important thing now for sustainable development. And to have a title like this and to have a conference, on multifunctional material is a great opportunity for the young scientists from India and abroad. And I mean, the battery, like we have Professor Rameshwaran from Nepal, then we have Professor Swaminathan from SET, Professor Ramaswamy from Mauritius, and the many others, So definitely it is going to be a very, very useful and meaningful interactions in the next 2 days. I congratulate once again the organizers on behalf of SET. And SET has been very instrumental in organizing many things, particularly during the pandemic, So, and as Professor Prabhu has narrated very, very briefly and very, of course, very impressively that the various activities of SET, we have been doing it. So thank you, Prabhu sir, for that. And I once again congratulate and I welcome all the speakers from various countries to have a good platform and to interact and to display their work. And thank you very much once again for giving this opportunity to Association of Chemistry Teachers to collaborate with the college and to organize one more workshop. Thank you very much.
Thank you so much, sir, for your word of wisdom. Thank you so much. Now I request Mrs. Sandhya Patil, ma'am, co-convener of the conference, to propose a vote of thanks for this inaugural function.
A very good morning to all the dignitaries and everyone present here. We have come to the end of inaugural session, and it is my pleasure to propose vote of thanks to all the stakeholders who made this event possible. Firstly, I would like to thank Honorable Chief Guest Dr. Punadurai Ramasamy, who has graced the event, and he has taken the time from his busy schedule to enrich us with the knowledge. I thank respected international and national speakers for accepting the invitation to deliver talks on various topics of their specialization. I mention my sincere thanks to respected President Dr. Brijesh Pare and Secretary Dr. D.V. Prabhu sir of SCT for their words of knowledge. I thank all the members of SCT and special thanks to Professor W.B. Gurnule sir for all his support in organizing this conference. An event like this cannot occur overnight. It requires planning, and we are fortunate to be backed by motivation of management members of JVM's Degree College. I heartily thank
sorry, Sandhya ma'am. My apologies. I missed some part. I'm really sorry for that. I request Mrs. Harshada Niju to give the introduction of chief guest for the function. My apologies.
That's what I was also thinking. Okay.
Thank you, Savita, for this part. Very good morning once again, everyone. I am very much privileged to introduce to you the Honorable Chief Guest of the virtual international conference on multifunctional advanced materials, VICMAM 2021, Dr. Punadurai Ramasamy sir. Sir was born in Mauritius and he has completed his education in India. He has completed his BSc Honours, MSc in Chemistry and PhD in Physical Chemistry in 1996 from University of Delhi, India. Sir's doctoral research work was done at the Physical Chemistry Laboratory, University of Delhi, under the supervision of late Dr. R.K. Padi and Dr. Rita Kakkar. In his professional career, Sir has been a visiting professor in University of Johannesburg, Professor Extraordinaris, University of South Africa, visiting professor, King South University, and has been an academician since 1997. Currently, Sir is teaching in Merton College, Mauritius, Ordinary and Advanced Levels Chemistry, as well as in University of Mauritius, in both Department of Chemistry and Department of Chemical Engineering. Sir has been awarded the Best Mauritian Scientist in 2016. He's been a scientific board advisory member of the Organization of the Prohibition of Chemical Weapons since 2021, since 2016 till date. 60 undergraduate, 10 postgraduate students have completed their research projects under his supervision, and 8 research scholars have completed their PhD under his guidance, and currently there are 5 research scholars doing their PhD under Sir's supervision. Sir has published 237 papers and has been at the editorial board of several books and has several books published in his name. Sir has completed 6 research projects funded by the University of Mauritius, and he has 3 ongoing research projects again funded by University of Mauritius and other funding agencies. I would like to mention a few research projects of his. Investigating human health and environmental impacts associated with chemical hazardous waste management use and disposal, as well as capacity building strategies, requirements for chemical safety and security in the Mauritian context, funded by the Tertiary Education Commission, and has received a funding of 100,000 US dollars, and antimicrobial activity of polyiodide complexes of Sandwich Group 1 crown ethers, funded by University of Mauritius and Ajman University, and has funding of 20,000 US dollars. Sir is one of the editors of the journal Open Chemistry published by D. Buter. Sir has participated in several international conferences, giving keynote addresses, and has been invited for many oral and poster presentations. Sir is a multitasker. He is not only in the forefront in the research and academic, but he also plays key roles in the field of administration. He is an associate editor, Research Journal of Chemistry and Environment, and advisory board member of Asian Journal of Chemistry. Sir is a reviewer of physical chemistry, chemical physics, chemical reviews, and several other journals. He is a committee member of the Project ChemLab, Journal of Chemical Education, American Chemical Society, Royal Society of Chemistry, International Congress of Chemistry, and many more. He is a high power committee member for scholarship, Ministry of Education, Culture, and Human Resource, Mauritius, and is a member of many other societies and committees. He has been a coordinator for International Congress of Chemistry and Environment in India, Indore, and has organized first workshop Computational Chemistry and its application part of ICCS in 2006. And many other such high profile events in different countries like UK, China, Poland, USA, etc. The list is just endless, and I might take the entire day to mention all the achievements and accomplishments of Sir. We are very much honored to have you here amongst us as the Honorable Chief Guest of today's conference. Sir, now I request you to address all the participants who are eagerly waiting to listen to you. Over to you, sir. Thank you.
Oh, thank you very much, madam. I hope you can hear me properly.
Yes, sir, we can hear you, sir.
Thank you very much. So first of all, a very good, for us it's still before noon, a very good afternoon to everyone who joining for this virtual conference. The organizers, the administrators, distinguished participants of this virtual conference, ladies and gentlemen, all protocols observed. I have the pleasure to address you as a chief guest for this virtual conference. I've realized that whenever I participate in a virtual conference, just talking to the participants sometimes lead to a void situation. So I thought that I should prepare a small PowerPoint, right? So I will share the PowerPoint with you, and I hope that everything goes well. So is this PowerPoint visible to everyone?
Yes, sir.
Yes. Thank you. So thank you very much again. So again, it's my pleasure to address you as the chief guest for this virtual international conference on multifunctional advanced materials. I think that this is an excellent initiative in the COVID-19 pandemic. Remember that we are doing science, and science cannot be done like in isolation. We need to collaborate, we need to discuss, we need to have scientific interactions. But you may realize that due to the COVID-19 pandemic, there have been several issues with traveling and restrictions in several countries, and thus the face-to-face meeting that we used to have as formal conference is now becoming difficult. But thanks to technology, that we are now able to have a virtual platform that we are still able to have the scientific interaction and discussion. I think that this is very important. Now, the scientific interactions, it's not only with respect to those who are really experts in the field, but I think it's very important for young scientists also. It's a two-way traffic. Both will learn from each other. I think that experts will share the experience that they have really gathered, and young scientists can really take the good message from these experts, and these messages can really be useful for their own career, right? And what I think that is very important now with respect to this virtual conference, I had a look at the program, and I can say that there is a wide range of talks, right, covering research on multifunctional advanced materials. And these are important to contribute to the country needs, because remember that we can't just do research because we are doing research. It has to contribute to the humanity. And one way to ensure that is to have research focus towards the country needs. And don't forget that we also have now the Sustainable Development Goals. And whenever projects are really being thought, being planned, it's always good to keep the SDGs in mind. Young scientists, of course, I think I have a very good experience with young scientists. And I think that with some good training and good mentorship, they can really contribute to the whole concept of innovation. And innovation is very important in research, because this will lead to results that are really useful to the humanity, right? But then based on my experience, I would like just to share a few points with you, right? So be very careful when young scientists are really embarking on research. Ensure that you carry out the proper literature review. It's very easy to come up with a research and say that, no, it doesn't exist, nobody has done this, but are you sure? Have you checked properly? Because it's really meaningless to really embark on research that has already been like you have results already available in literature, and you're not just contributing to anything, right? So a careful literature review is, I think, very vital. And the next, I think that the self-dependent, yes.
Sir, actually, your slides are not changing. Still on the first slide, sir.
What about now?
No, yes, sir. Yes, sir. We are on the third slide, I suppose. Some advice literature review self-dependent.
Yes, I'm sorry. I'm sorry. So you maybe I'm very sorry for that.
Slideshow also. No, sir. It's okay, sir. You need to do the slideshow also, sir.
Sorry.
Yeah. Slideshow, sir. You are
okay.
Yeah. Yes, sir.
Yeah. So I'm very sorry for this technical issue. I hope that at least you could follow what I was trying to mean, right? But let me come to this point again. So like now, if I go to the previous one, can you see? I've changed the slide.
No, sir. We're still on the... Yeah.
I'm sorry for this technical issue, right? But for this one, so the advice is, so can you read this slide, some advice? Is this okay?
Yes, sir. Some advice, literature review, self-dependent.
Right. Okay. So, yes, again, I'm sorry for the technical issue, but what I'm trying to say is that young scientists can really embark on good research if they get good mentoring, good support. But then, and these are very important for the innovation. So, but before I really end up, I'd like to share some advice with young scientists who will really embark on research. So be very careful that you carry out a proper literature review, because it's very easy, as I said, to say that this was not done, this has not been done, and so on and so on. But you will be surprised that the literature is very vast. So you have to check very well before you really embark on a project. And the next point that you have to take in mind is to be self-dependent. So when you are really embarking on research, don't expect that you will be getting support from your friends, from your PhD supervisor, and so on. They are here as an advisor. They are here as a mentor, for mentoring yourself, but the hard work has to be done from you. And remember that if you do hard work, if you try to focus on what you are doing, have good plans in mind, you'll be surprised that results will come and innovations will be around. That you have to be sure of yourself. And you have to be patient, because you have to realize that science research is carried out by doing experiments. And it's not always sure that whenever you're doing an experiment that you will end up always with positive results. You may be ending up with negative results, but these negative results are very important for you to really make yourself more mature, so that you can really look into the problems that you are looking at. Well, the list is long. I don't want to give a lecture on the advice on how to embark on research, but these are some of the highlights that I would like to share, right? So with these, I wish all of you an excellent virtual meeting, right? So I'm sorry if we had some technical issue, but these are the issues that sometimes we get with technology. I wish everyone well, and I hope that the participants of this meeting will really benefit from the experts who are really contributing. And a big thanks to the organizers who are putting forward a platform so that we can have scientific discussions. Thank you very much again. Have a good day to everyone.
Very thank you, sir, for such a wonderful talk. I definitely know that the researchers would be following all the advices that you have provided them in this in their near future. Thank you so much, sir, for your speech, sir. Now,
my pleasure.
Thank you. I now request Sandhya ma'am to propose the vote of thanks.
Good afternoon, all the dignitaries. We have come to the end of inaugural session, and it is my pleasure to propose the vote of thanks to all the stakeholders who made this event possible. Firstly, I would like to thank Honorable Chief Guest Dr. Punadurai Ramasamy, who has graced the event by his presence and spared time from his busy schedule to enrich us with his knowledge and motivate us to do research. I thank respected international and national speakers for accepting the invitation to deliver talks on various topics of their specialization. I mention my sincere thanks to respected President Dr. Brijesh Paresar and Secretary Dr. D.V. Prabhu sir of ACT for their words of knowledge. I thank all the members of ACT and special thanks to Professor W.B. Gurnule sir for all his support in organizing this conference. An event like this cannot occur overnight. It requires the planning, and we are fortunate to be backed by motivation of management members of JVM's Degree College. I heartily thank our principal, Dr. Lina Sarkar, for her wholehearted support at each and every step in planning. I would like to thank the national and international participants. I thank the teaching and non-teaching staff for the hard work. And finally, I thank each and everyone present here. Now we will begin with the technical session. I am honored to introduce today's guest speaker, Dr. Rameshwar Adhikari. He has acquired his master's degree from Tribhuvan University, Kathmandu, Nepal, and doctorate from Institute of Physical Chemistry and Electrochemistry, Germany. He had started his journey as a lecturer for chemistry in Trichandra campus, Kathmandu, and is presently the Executive Director at Research Center of Applied Science and Technology, Tribhuvan University, Kathmandu, Nepal. He has also been involved in various professional organizations since 1992. For example, he has been the General Secretary of Nepal Chemical Society twice. He is currently the member of the German Engineer Society and Federation of Asian Polymer Societies, along with being the Secretary of Humboldt Club Nepal and an associate member of Cameron Committee. He is national representative for Committee for Chemical Education and Polymer Division of IUPAC. He has done an extensive research in various areas like electron microscopy, nano and biomedicinal materials, nanostructural polymers, then polymer modification and diagnostics, etc. He has published more than 130 research papers and book chapters in international journals and books. He has supervised more than 70 MSc, BSc candidates and 15 PhD students. Today, Sir is going to enlighten us on the topic of structure property correlations in biodegradable polymer composites. Sir, I request you to commence the very awaited session. Thank you.
Thank you, madam. Thank you so much for a very kind introduction. I just want to share my screen. So this Google platform is quite new for me. So I think I can share this one. Sir, can you see my slides?
Yes, sir.
Yes, sir. Yes, sir.
Wonderful. Thank you. It's coming. Okay. I will also go to full screen mode. So I think it is in the full screen mode.
Yes, sir.
Yes, sir. Yes, sir. We can see the screen. Yes. Sir.
So thank you. Thank you so much. Thank you so much. Very good. Good morning. Good afternoon. Actually, in Kathmandu, it has already become 12:30. Good afternoon, everybody. So thank you so much for this very kind invitation to attend this international conference and to share some of our results. Very grateful to Professor Gurnule. Vasudevji, namaskar. Thank you so much for giving me this opportunity to come
Thank you, sir.
Over to you through this online platform. Thank you so much, principal of the college who is organizing this one. I'm also very, very much grateful to Dr. Prabhu and Professor Pari, who are leading the Chemistry Teachers Association, which is really doing a wonderful job for bringing us into the networking, connecting us so that we can continue our collaboration and so on. Thank you so much. Very grateful to you. So, Professor Ramaswamy Punadara, he is very active in organizing conferences, educating the young scientists. He was also talking about the young scientist motivation. Very, very nice to listen to you, Professor Ramaswamy. I met you in 2003 in your university, long ago. It was very nice to meet you. It is we are today on August 9, and it is very close to August 12, which is also the International Youth Day. So we are organizing this conference on the eve of International Youth Day. So it is very nice to dedicate these activities to the young scientists. So without delay, I want to go to my topic, structure property correlation in biodegradable polymer composites. I will mainly focus on morphology and mechanical properties characterization. So because we are talking about the multifunctional advanced materials, I don't know whether I will be talking about partly about the low-tech material and partly about advanced materials, about the biodegradable composites. So this is the outline of my presentation. After a brief introduction to the topic and the objectives, then I will go to three topics on biodegradable copolyester and chitosan composites, then the composites with microcrystalline cellulose, then with the multi-wall carbon nanotube composites. So let us begin with the introduction. Yeah, we all know that plastics have a very big influence on our life. They have many application areas. So they have invaded our society in various ways, like health sciences, biomaterials are made out of them. A part of medicines are also the plastics. They are very essential in cosmetics, which is also very important for our society today. Transportation is very important. So there are many areas. And if we go very deeply, we can even find that these devils of today can even be treated as something that can help us to protect the environment. Okay, but this is not the topic I'm going to talk about today. The main reason why we need plastics is their weight, So for 100 gram of the product, if we want to make some packaging in a glass, we need some 100 gram again, But if we take some plastics, then it is only a few grams. This is the main reason why we really need plastics. One of the main reasons. But they have created quite big problems. So, Madam Sir, there is quite a big noise coming. If the colleagues could mute yourself, it will be easier. Okay, this is one of the reflection of the problems that are created by plastics. And this kind of scenario can be seen everywhere in the cities, especially in the towns. So therefore, the general motivation of this work is as follows. So already mentioned, we need plastics, but it would be nice if the plastics could degrade, and if we could control the degradation process of the plastics. And the second important thing is, if we could use the things that are available, renewable in the nature, that could reinforce the plastics. And the third one is, after the use of the plastics, if we could make something good out of it, from waste to the materials. That should not be necessarily the high-tech materials. So this is the general motivation. With this motivation, let me start with the experimental part. For the research that I'm going to present, these are all published research. I simply forgot to mention here the publications. Anyway, the matrix material, the main polymeric materials that we are using is a biodegradable thermoplastics. The chemical structure is shown here. This is a copolymer of polybutylene adipate and terephthalate, abbreviated as PBAT, or it is also called Ecoflex, that is commercialized by the company BASF. So when we have a look on this material with electron microscope, or in this case, the scanning force microscope, this is 10 micrometer scale, and this is 2 micrometer scale. You can see small globular structures that we call spherulites. And on higher magnification, we can see in every globular structures, spherulites, there are tiny, surd, worm-like lamellar structures. And this is typical of well-known, very low-density polyethylene. So therefore, naturally, by virtue of these properties, structural properties of this material, these behave practically as low-density polyethylene material. Therefore, they are very useful also in packaging. These are the commercial advertisement of the company, BASF. So they have advertised it, and this is also true, that they can be wonderfully utilized for packaging of food materials, medicine, and so on. And these are the properties of these materials measured by different techniques: molecular weight, glass transition temperature very similar to that of polyethylene, and melting point is quite low. Okay, for the materials as filler to reinforce, we utilized in this work 3 kinds of materials. One of the natural fibers materials, chitosan, that can be obtained from deacetylation of chitin. Chitin can be obtained from any chitinous animals, insects. Then we use microcrystalline cellulose obtained from Woodstock. Woodstock, not only Woodstock, but microcrystalline cellulose can be extracted from any kind of cellulosic material grown in agriculture or in the forest. Then finally, we use some high-tech material, multi-wall carbon nanotubes, in an effort to prepare conducting nanocomposite material. So we start with the characterization technique. These are the different techniques that we used. The samples prepared mainly by melt processing above 200 degrees Celsius. It is quite above the melting temperature of the polymer. And they were characterized by various techniques, but I will focus, or I will give a glimpse of the results from electron microscopy, some from transmission electron microscopy, a couple of pictures, and mainly from scanning electron microscopy. Then we will show some results from tensile testing done at room temperature, and some results from gel permeation chromatography utilizing polystyrene as the standard. So let me go to the EcoFlex or PBAT chitosan composites. So we all know that chitosan is very important material, naturally available, polysaccharide. The structure of the material is shown here. And it is known that it has many interesting properties, not toxic, biodegradable easily, biocompatible. They have very well-known antimicrobial activities, and they can be turned easily into the films, and they can also be utilized in adsorption of heavy metals and so on, as they have very well-known, very good chelation properties. Easily available, of course. Price is not very high. It is quite low cost, and stability of the material is also not bad. So how to do it? How to make it? It is really very established method. Very established method of synthesizing or extracting chitin from chitosanic chitin-containing insects. So how do we synthesize the chitosan is shown here. In this particular work, we collect the prawn cells. They are washed, ground to small, fine powder, sieved. Then they are treated with hydrochloric acid. So that after that the powder is free from minerals. So after the acid treatment, then this is treated with sodium hydroxide, caustic soda, for several hours. Then we have chitin. This chitin can be then turned into chitosan by treating with strong caustic soda solution. In this case, we take 40% caustic soda solution and 70% caustic soda solution. By the reaction with these materials, the chitin turns into the chitosan. So we have named simply them chitosan 40 and chitosan 70, just by taking the concentration of caustic soda that was taken at the end of the name. Okay, after that, how does the chitosan look like? So as already mentioned, the chitosan was extracted basically from chitin-containing insect, in this case, the prawn cells. So they are composed of cells-like structures, the plate-like structures. The scale bar here is 200 micrometer. This length is 200 microns. So this is, of course, the scanning electron micrograph. We can see wonderfully arranged, wide, long, flat chitosan structures. So what do we do? Now we take this material, then process this together with polymer at 240 degrees Celsius, and the composition looks like this. The composite material looks like this under electron micrograph, scanning electron microscope. So this is a composite of PBAT and chitosan with the composition 80% PBAT EcoFlex and 20% by weight of the chitin. This is the lower magnification, and this is a higher magnification image of the composite of the blend. You can see that this is outer part is in the lower higher magnification. Outer part is the degradable polymer. outer part, and this is the boundary between them, and this is the chitosan, which are also arranged in the form of layers. So we can see mainly that without using any kind of compatibilizer, the degradable polymer is, the PBAT is compatible with this chitosan. Okay, this is about the structural characterization. I just want to stop here telling that the polymer and chitosan can be compounded very easily by melt mixing and can be turned into very well-formed sheets. So the small pieces of those have been shown here. So this is the 100% polymer. And there are different kind of other polymers containing 5%, 10%, 20%, 60% chitosan and the polymer. So these were the samples which were composted, buried under the soil in given conditions for several weeks, 8 weeks in this case. So the sample of these given sizes were taken. They were buried about 10 centimeters under the soil, composted, and regularly the weight was measured using this formula. So you can see already in this photograph that after 8 weeks, some of the composites have degraded or they have disintegrated into the very small pieces. In some cases, it was not possible to find out the composite films inside the soil. And when we look at the composites in the electron micrograph, in the SEM in this case, then we see that after the degradation, this is inside and this is the outside of the film. Inside, you can see the fibrillar structures of the still not degraded chitosan and also the polymer. And this is the outside surface showing several cracks on it. And these cracks allow more bacteria, more degrading substances, including water, to enter into it and make this substance quite degradable. So what we can find in summary is quite well dispersion of chitosan can be achieved by melt processing, and up to 60% loading was achieved easily. But I should tell you, I did not show you the results here, that the mechanical stability, however, degraded at higher percentage of filler loading. Thermostability is okay. Composites are compostable as already shown, and because by virtue of the low mechanical stability, they are useful only for low load-bearing applications, for example, packaging. Okay, let me go to another topic. The composites with microcrystalline cellulose. So how was it done? The microcrystalline cellulose can be easily extracted from cellulosic materials. Here in this case, the wheat stock. This is really standard method too. In brief, the wheat stock is collected. They were powder like this. They were subjected to mercerization treatment with caustic soda, low concentration of caustic soda. Then they were bleached with sodium hypochlorite so that the coloring substances could be disappeared. They were subjected to steam, so-called steam explosion, followed by acid hydrolysis and neutralization. Acid hydrolysis at high concentration, strong acid hydrolysis will turn the microcrystalline cellulose even to nanocrystalline cellulose. But this is not what we are going to talk about today. So this way, we prepare the microcrystalline cellulose. And then, how does it look like? So these are the fibers embedded in the plastics. This colorful, this is because of the polarizing in the optical micrograph. This is the optical micrograph of the composite. You can see the fibers. This is 300 micrometer scale bar. So they are several hundred microns wide and several hundred microns long fibers. So when we do the processing, the treatment with several substances, as mentioned before, then we have microcrystalline cellulose. which leads to the formation of fibrillar structures, which are several hundred micrometer thick and several long and several micros thick fibers. So I'm not going to talk in the detail, just a glimpse of the nanocrystalline cellulose. This is the transmission electron micrograph of the sample. You can also see white droplets onto the surface of the fibers. These droplets accumulated on the fiber substrate indicates the strongly hydrophilic nature of the fibers, which is mainly due to the high surface area of the nanofibers. Then the question would be, how do the corresponding composites behave mechanically? So in this case, what we did, we made the composites of all these materials with PBAT, the polymer, the biodegradable polymer, and then we did the tensile testing. So you can see here the tensile stress strain curves of the material with ecoplex, and these fibers were from the bamboos. It is not from the wheatstock. I'm sorry, but they have very similar structures. So what we see is the polymer is very highly ductile. It shows elongation at break of several hundred up to 800%. The yield strength is not so high, but when we add the fibers, the macro fibers into it, up to 40%, we can do it very easily. But when we add even 10% or 20% of the floor into it, then from 800% elongation at break, it drops into some 200 or 300%. And the same thing happens also with the microcrystalline, nanocrystalline cellulose, with some deviations, some differences in the mechanical properties, but practically the microcrystalline cellulose and nanocrystalline cellulose do not bring much reinforcement or much advantages in the crystalline, the composite materials with the PBAT. So now what we saw is when there is no fibers, microfibers or any kind of cellulosic fibers, the material behaves in a quite ductile manner. And when the material is not so much, the fibers are not, content is not so much high, then still the material behaves in a ductile manner, but a high percentage of filler makes the sample brittle. What is the reason? To find the reasons, what we do is we take the sample after tensile testing to electron micrograph. What we do is, so after tensile testing, the broken samples are there. We take the broken sample, and from the fracture surface, we prepare the sample specimens, and the fracture surface of the specimens are brought into the electron microscope. And here are two results. On the left, you can see the pure PBAT, the pure ecoflex. You can see upper part, the lower magnification, and in the lower part, the higher magnification. What you see is the highly fibrillar structures of the material. Everywhere, all over the sample. This is 200 micrometer, and this is through the cross-section of the sample. You can see the fibrillar structure produced. This happens due to the absorption of a large amount of deformation energy. This is the higher magnification, the fibrillar structures, and that leads the sample to the ductility. But if we go to the sample with 40% microcrystalline cellulose, then what we see is you can see this fibrillar structure localized, not everywhere, not all over the sample. And this localization is, the fibrillar structure is very similar as in the pure sample. But due to the localization of fibrillation of the material that absorb the deformation energy, the sample behave not very brittle, but much lower ductile in this case. Okay, About the degradation of this material, as in the previous case, we brought it into the soil. You can see that this is the sample with 10% of microcrystalline cellulose. This is with 40% of microcrystalline cellulose, and this is with 60%. When we bring this material for 2 months into the soil, then all of these materials seem to quite disintegrate into small pieces. After 4 months, one of the sample was not, I don't mean amorphous in the crystalline sense here, it was very powdery. So it was disintegrated, it was scattered right after we touched it. So it became like a very fine powder. So the rest of the samples you could collect and you could touch it. So what we can see that composites are degrading on soil composting with bacterial and fungal attacks. The fungal attacks and bacterial attacks I'm not going to discuss today. The study showed higher microcrystalline cellulose content degraded earlier, as expected, because they provide more interaction, more surface area for interaction with various degrading agents. Then the question comes, how do they look like under electron microscope? This is a scanning electron micrograph of the samples. So on the top, after 2 months, and on the bottom, after 4 months. In both the cases, you can see that the beautiful structures of the composite material, after 4 months, this is the lower magnification, this is higher magnification, they are turned into voids and much smaller fibrillary structures. Therefore, molecular weight of the materials could be expected to be reduced drastically after these disintegrated structures. So this was done with the composite material with microcrystalline cellulose added by 28%. So when we analyze by gel permeation chromatography how the molecular weight changes in such circumstances, I show you here only some of the results. First of all, indicated here for the PBAT, the biodegradable polymer, the commercial polymer, the need sample has the molecular weight of about 50 K. When we take the composite material and we degrade it for 4 months, then the molecular weight goes below 20 K. And similar behavior, although there is some variation is there, similar behavior is observed in other composites also, but we can see that there is a drastic reduction of molecular weight of the materials after 4 months. But still we have to think about it that the molecular weight is not disintegrated. The molecule is not disintegrated. The molecule is still there. This is still a polymer maybe perhaps in the form of microplastics. Therefore, the molecular weight of the PBAT in the composite decreased with MCC content during soil composite, but not completely. So let me go to the last topic. Just few words, I will talk about it. So I am almost at the end of my presentation. It will not take so long. Within few minutes, I'm going to finish. So, okay, till now, we talked about the materials that can be utilized for packaging, biodegradable packaging. They are not much load-bearing, but they are quite good, thermally stable. Not so bad mechanical properties, but they are useful for low load-bearing applications of packaging. And now the question is, can we make some high-tech material, some multifunctional materials out of it? In order to study it, we studied the composites of the EcoFlex with multi-wall carbon nanotubes, the multi-wall carbon nanotubes being commercially available in the market. So in these pictures, you can see the morphology of the composites in two compositions. One is the polymer with 2 weight % of multi-wall carbon nanotube prepared by melt mixing at 240 degrees Celsius using a microcompounder. And another one is the same polymer with higher amount of multi-wall carbon nanotubes prepared in the same way. In the first glance, what you can see is that in the first picture, there are many, many white, black dots, dark dots, which are the structures corresponding to multi-wall carbon nanotubes. They, in the thin film used for transmission electron microscopy, they scatter the electrons in much higher scale, so they appear darker than the polymer. The organic polymer do allow most of the electrons pass through it. Therefore, they appear brighter in the transmission electron micrographs. So anyway, we have made detailed studies on these materials. This is only two representative transmission electron micrographs. And what's about their mechanical properties? Very interestingly, they have quite good mechanical properties, but in the similar line as with the composites with chitosan and microcrystalline cellulose. Have a look at the dark. This black line is for pure ecoplex. Then we add different amount of multi-wall carbon nanotube, 0.5% by weight, 3%, and 10% by virtue of very high aspect ratio of the multi-wall carbon nanotubes. We see there is a quite drastic decrease in the elongation at break, but at the same time, we also see the strength of the material increases, the stiffness of the material increases, as shown by the inclination of the initial part of the stress strain curves, and also there is an increase in the yield strength of the materials. Okay, but still, these are very flexible materials, can be utilized for several flexible electronic applications. But generally, to achieve a good conducting properties, we need not more than 1% of the carbon nanotubes, which under that conditions, the multi-wall carbon nanotube composites of the PB80 shows elongation at break of several 100%. So we are also studying this material for piezoelectric properties right now. So just to give you the glimpse of this material, what we did is we just utilized the film of this material to complete the circuit and to light the bulb. And the result was, you can see this this way the circuit was completed, and you can see the light could be easily burned. So this is also the summary of this part. So let me conclude my lecture in general sense. So we have found that the fabrication of compostable composite material films with PB80 using different kind of pillar was easily done. So high fibrillation of the material was found to be the reason behind the high ductility of the PB80, while the blends with low filler content, while the blends with higher filler content showed lower ductility, which was due to high fibrillation but localized fibrillation. And then we also found by gel permeation chromatography that there is no complete degradation of the polymer after 4 months, hinting at the microplastics formation for sure. So more study are underway for molecular mechanisms characterization of degradation using different kind of strains of bacteria. This is going on right now. And we see that there is more efforts needed to control the mechanical properties, because the materials can be utilized for good packaging, but for the application that which requires high strength of the materials, these are not so good. So I am at the end of my presentation. Just to conclude my presentation with some pictures, I want to show you. Please visit to Kathmandu once the situation becomes normal. I am sure one day it will be normal. Please visit Kathmandu and visit the living goddess Kumari. So this is several hundred years of a tradition in Nepal. We can, with a good appointment, we can meet the living goddess Kumari in Kathmandu. You are very welcome to come here. And this Darbar Square, Bhaktapur, it was completely destroyed in 2015 earthquake, as many others cultural heritage of Kathmandu Valley. Now the city is almost completely restored. So after the pandemic is over, you are invited to visit our Bhaktapur, the city of the deities. And also, this is one of the biggest stupas in the world, Bodhanath, where the history says that the very famous Rinpoche, the Guru Padmasambhava, visited this place in Kathmandu, and this is one of the very important places for Buddhists in the world. Also, of course, please visit us to also to see the high mountains where Nilakantha, Lord Nilakantha meditates very close to Manasarovar. And you will be wondered to also to know that Nepal has the places where the rice is grown in the highest altitude of the world. This is the Tila Valley in Jumla, Tila Valley in Jumla district. It is above 3,000 meter high, and this is the village, and the people are growing rice, paddy in this place. So this is all I want to show you. So thank you so much for your very kind attention. I am very grateful, very thankful for invitation, and hopefully I will be able to come back to India to meet Professor Gurnule and other friends, Professor Prabhu, Professor Pare, and to visit holy places there. So thank you so much. Let us keep our friendship, let us keep our networking, let us exchange our ideas, and let us continue our collaboration despite all the difficulties that we have. Thank you. Namaskar.
Thank you, sir. We have come to the end of technical session 1. I express my sincere thanks to Dr. Rameshwar Adhikari sir for enriching us with the precious knowledge on such an important topic of biodegradable materials, which are need of the hour. We are really grateful to you, sir, for giving information on how to prepare the biodegradable materials like cytosine, microcrystalline, cellulose, etc., and study their degradation time. After looking at the pictures, we are really interested to visit Nepal, and we will definitely like to come there, sir. Thank you so much.
Please do that. Thank you.
Now, I request...
excuse me, ma'am. May I ask a question?
Yes, ma'am.
Good afternoon, sir. It was very presentable. Everything was so clearly understood. I have risen with 2 doubts. May I ask you, sir? Rameshwar,
yes,
sir?
yes, definitely. Go ahead.
Yes, sir. The first question rises that when you go on degrading, means mercerization is done, then you demineralize and everything. How do you get to know that the microcrystals are formed and you have not touched the nanocrystal level? Do you need every time the analysis is required at every point of time that you take the sample and get it analyzed and see the nanocrystalline structure or microcrystalline structure is formed and then the process is stopped? Is it like that? And second question is, you said about the degradation process. So when you started with 20%, 40%, and 60% of cellulose and the polymer matrix, you said that 60% almost changed to powder form, and so that you couldn't collect and analyze the sample. So it's quite possible that you have to maintain the degradation by maintaining the cellulose composition, chitosan composition with the polymer composite. Is it so, sir? Please, sir.
For the first question, I suppose you are asking in general terms if we are making microcrystalline or nanocrystalline material, and is it necessary to take it to the electron microscope or X-ray diffraction and to see if it is nanocrystalline or not. Yeah, this is the question. So my answer here is no. It is not necessary to because there are some other preliminary methods that tells us whether the samples are nanocrystalline or not. The thing is, first of all, the method is standard. And if the other people have been able to prove that this is nanocrystalline, ours should be nanocrystalline too. But we should be sure. For that, what I recommend is what I do. What we do is we just take the sample, we make the suspension in the given solvent, water or whatever, in which it can be suspended. And in the suspension, we pass the laser light. And if the laser light is scattered, as the milk does or blood does, in a good way, then we know that there is an nanocrystalline material. So this is the first thing. And for the second point, you asked about the degradation studies and chitosan or whatever. Yeah. So I did not recognize completely your second part of the question. Did you ask me about how can we be sure about the degradation, or can you repeat, please, very quickly?
Yes, sir. Yes, sir. Regarding the first question, yes, sir, I got the answer. Means you were saying about the Tyndall effect. Means the mostly the colloids part, which if we get the crystalline form, we can very well understand with the help of that. Fine, sir. Second part is I was asking, we have to regulate means the proportion of the chitosan with the polymer composite. It shouldn't be that like the chitosan should not be much in number so that the polymer cannot be collected and analyzed. That proportion of mixing the chitosan composites with the polymers has to be adjusted to get the material in the final stage so that we can analyze. That's what I wanted to say. I wanted to ask, sir.
I'm still unable to understand the question completely, but I will tell you what I understood. The first thing is, if we take more and more nanocrystalline material into any kind of matrix, the chance that the dispersion, the interaction of the nanomaterial with the substrate with the matrix is more and more due to higher surface area of the nanoparticles. Yeah. Okay. So it gives us the chance for, if there are some bacteria or fungi or whatever else that disperse into water and go into the interface and degrade the material, the opportunity is higher. So it creates the opportunity so that the higher degradation is possible. Of course, there are many other factors too. Okay, this is what I wanted to tell you. But this is not the amount, but this is amount of the nanomaterial that leads more degradation, but this is the more dispersion of the material. If dispersion is higher, then it can initiate more degradation. Okay, but if you are interested to interact more on our topic, we have done extensive studies on this. Please write me an email.
Thank you so much, sir.
Okay.
Thank you so much.
Thank you for your question.
As ma'am said, really the session was so much transparent that there are no queries on the YouTube link that we had shared. Thank you so much, sir, for addressing to the query. Then now I request Assistant Professor Harshada Niju.
Thank you. Thank you so much.
Thank you, sir. So I request Assistant Professor Harshada Niju ma'am to introduce eminent speaker for technical session 2. Thank you.
Thank you so much, ma'am. Good afternoon, one and all, once again. Second eminent speaker for the day is Shri Thinakaran Narayanan, sir. Sir has completed his Master of Science in Manufacturing Engineering, UTM, and has completed numerous skill-based advanced diploma courses. Sir has teaching experience of 19 years and is currently employed with Higher National Youth Skill Institute of Sepang, Malaysia. He's been teaching theory and practical lessons in plastic injection from 2011 till date. He's a teaching experience in heavy machinery mechanics, architectural design, panel beating, and spray painting. Sir is also a part of research and development in waste plastic and agricultural waste since 2015. He has been humble enough to mention his varied work experience with us and has reached his position today. Sir has been a plenary speaker for many international conferences and has also been a part of jury for many international competitions related to research and innovations. He is a certified coordinator of Prior Performance Achievement Centers, HAPs, at IKTBN and Head of the Innovation and Design Program at IKTBN SIPA. So as a part of panel for Ministry of Youth and Sports CGPA final examination questions in heavy machinery mechanics, and is also representative of heavy machinery mechanics in Timbong IKTBN Technical Development Unit. Sir has won many awards and gold medals in many innovation competitions at international level. I would like to mention some of the special awards Sir has received. He's been awarded a special award which was presented by Mr. Syed Sadiq Abdul Rahman, Ministry of Youth and Sports for Individual Category 2019, IT Trainer Award 2019 presented by Mr. Syed Sadiq Abdul Rahman, Ministry of Youth and Sports. Best Work Award for the publication of The Effects of Sodium Hydroxide Surface Treatment on Dried Banana Leaves Fiber, DBLF, to prepare and characterize degradable plastic materials with waste polypropylene by ACTA Scientific Agriculture publication. Sir has 9 research papers to his credit and has been a reviewer for international journals. He has been an author for international journal books and has been on editor board for international journals as well. We are very privileged to have you, sir, here today as one of the eminent speakers. And now I request you, sir, to kindly take over from here.
Hi, very good afternoon, madam. I'm Tinagaran Narayanan from Malaysia. Can you audible me?
Yes, sir, we can hear you, sir.
So shall I share my slide?
Yes, sir. Yes, sir.
Is it my slide is visible?
Yes, sir. It is visible, sir.
Okay, ma'am. Thank you so much. And before that, before I start my presentation, I have to say thank you to the organizing committee, Professor Vasudev, to giving me this opportunity to share my research. Actually, myself, I'm more to the industry application in plastic degradable material, composite, especially in the composite of polymer and fiber. So few of my research I will share about my research and my experience with the industrial, especially for the automobile and medical application. So I'm trying to start my presentation. Okay, right. Can you visible my first slide? It's about the topic.
Sir, have you started with the slideshow, sir?
Okay, sure. Madam, can you get my full slide?
So now it has gone blank, sir. You could see it earlier, just a few seconds back. Now it has gone blank, sir.
Okay, all right.
Yes, sir, it's visible now.
Is it in slideshow mode?
No, sir. No, not yet.
So I'm not sure, madam. Why cannot go to the full slide mode? I'm not sure why.
So if you can present your entire screen, then I guess the slideshow mode can be seen.
I think I can give you the hint. The same thing I had. So what you have to do is, you share the slide. Dr. Karan, I will tell you my what I did.
Sure,
same thing happened to me. What you do is you share the slide,
Then
Okay.
you go to your presentation and then make the slideshow.
Okay, sir. Okay, sir. Thank you, sir. Is it okay, ma'am?
Yes, sir. Yes, sir. Now it's in the slideshow.
Slideshow, is it?
I think no. I think no, because you shared your window.
Oh,
okay.
Yes, sorry. Yeah, yeah.
Yes.
So,
Okay. I'm trying to share.
You please share your tab.
Yeah. Okay, sir. Is it okay now? Is it okay, madam?
yes, sir. We can see your slide, but again, it is not in the slideshow mode.
Okay. So, or I'm continue with this. Can is it?
I think it's clear. It's okay. You can proceed.
Yes,
I mean,
sir.
no
Yes,
problem.
sir. We can actually go ahead with this.
Okay, madam. Thank you so much. All right. Sorry, this is not my slide. You. Okay. Shall I start now?
Yes, sir. Please, sir.
I shit. Okay. My topic is about physical and mechanical properties of non-treated and NOH, sodium hydroxide treated recycled polypropylene filled with dried banana leaf composites. Okay, first of all, I like to give the definition of the composite. Composite is the material consists of two or more than different material in the chemical and physical properties. There's a composite. So for my topic today I'm going to talk about the composite between plastics and nature fiber. So for the plastic, I'm going to choose a polypropylene that is under the category of thermoplastic. Basically, why I'm choose a polypropylene because of I'm teaching in plastic injection molding, basically plastic injection molding and plastic blown film for the industrial sector, for the industrial workers. So that there are a lot of waste and scrap generated during the teaching and learning activities. So I prefer the recycle, not the virgin polypropylene, recycled polypropylene. I'm choose because of the lot of abundance of scrap and material that generated during the activities, learning activities. The second one, my reinforcement filler is I prefer from the natural fiber. That is one of the major problem in Malaysia in agriculture industry. So I'm specified for the agriculture industry in cultivation product, such as in the banana sector. Okay. Is my slide movable?
So slides are not moving.
I don't know why suddenly happened like this. I couldn't share my slide.
So what you can do is you can share your whole screen and then you go on presentation mode.
Oh, okay.
You stop sharing this tab.
All right. Okay.
And you'll get that present screen option. So there you click on share your entire screen.
Okay, madam. Thank you.
So first option, next to raise hand, you'll see one box with an arrow. In that first option.
Okay. Yeah. No. Okay. But I don't know why I cannot share the screen. Entire screen just is visible is the only Google Meet, not my slide.
Yeah.
So
Yes, sir. You can click on entire screen, so your whole screen will be shared. Okay.
Okay. All right.
And then you can go to your presentation and do slideshow.
Okay.
So now you don't stop presenting. You can go to your presentation.
Okay. But
yes,
only
sir. Now, yeah, you can see that PPT icon below. There is you have PPT icon. Click on that. Yes. Yeah, and now you can click on slideshow.
Is it okay now?
Yes, sir.
Yes, sir. Perfect, sir. Now.
Okay,
yes,
okay, madam. Thank you so much. All right. The next is a problem. Okay, problem in plastics and nature fiber. The first, I like to address the problem in my side, in my learning and activities. The first is a plastics. Plastics, abundance of injection molding waste is generated, is producing during the teaching and learning activities with my school leaver students and industrial workers. So we prefer for the automotive and medical department for the industry, and the school student, yes, after 18 years old, they come and join our institution for the diploma level in injection molding. That our student is we prepare for the skilled workers. So the first problem is the abundance of the injection molding waste. So you can see this actually is what I mentioned here is 2 tons per year is actually is a very minimum of the waste that generated. Actually in industry almost 4 to 5 tons per day we wasted during our production manufacturing process. And what I did before I start my research, the first thing, all the waste I'm dumped to the landfill and scrapped in the post-consumer, actually, which is against the law and regulation in Malaysia. So, and then come to that point, we plan with my department staff, my faculty staff, and then we come out with a few ideas. And one of the idea is the composite. How we can process the old scrap plastic or waste plastic to become a new advanced material. The first problem is the abundance of injection molding waste. The second problem, why I'm choose what is a banana? Why I'm choose banana? And then banana is not the pseudostem. Actually, a lot of researchers, academicians, the past researchers, they more focus on the pseudostem. But myself, I prefer to the banana leaf, and specifically for the petiole. Okay, we can see there is a banana. Banana actually in Arabic we call is finger. It is a banana, and we can see that picture there. Banana have a banana flower, banana fruits, and banana tree, and perfectly I'm choose for the petiole. The petiole is the in our banana leaf. I'm choose that fiber going to use in my research. Why I'm choose banana leaf? Okay, first thing we can see there's a 3 stage of the banana leaf. The first is green leaf, the second is matured leaf or yellow color, and the dried one, the brown color. Okay, what is contains in the matured leaf? Okay, we can see there's a 9% of protein, 30% of fiber, 40% of starch, and balance 21% is moisture. Okay, the first thing. But I'm not going to choose the yellow color. I'm prefer for the dried leaf because there are problem that we didn't realize. Actually, for the global warming, not only the release gas of the carbon monoxide, actually the methane gas emits from the agriculture industry. So we can see that what are the main factors of the global warming. So produce 20% of methane gas from the dried banana leaf is released 20% methane gas. What is methane gas? Methane gas is harmful, 84 times more harmful than carbon monoxide, which is released by industry and automotive section. And these are the things, one of the factor that contribute to the global warming. And third factor, in Malaysia 2017, according to the Department of Agriculture, they have to stated 26.40% banana is the most highest production in 2017, which means when highest, the waste also, the agriculture waste also be the recorded the highest one. So these are the things I prefer to choose, especially the banana leaf, dried banana leaf for my composite material. And the third one, as we know, as we understand, all right, problem in composite failure. Why composite failure? We can see there's a picture between the matrix and reinforcement filler. Matrix is, I'm talking about the recycled polypropylene, and the filler are dried banana leaf. Basically, there are poor in intervention bonding between matrix and filler, and poor heat resistant, and they are become a more factor in the porous. It's create the porous between the filler and matrix, and the surface of this product will be very rough, and too many fiber will pull out during this process, during the we call it extrusion process in manufacturing. And the second part is when we know that plastic is a hydrophobic characteristic, which is water resistant, and nature fiber are more to the hydrophilic, which is absorb more water. So two different characteristics, how we going to be combined. So the second problem is high water absorption because of the hydrophilic characteristic of dried banana leaf, and easily can sink in water. All right. And the third one is unbalanced ratio. So I'm going to talk about the ratio between plastic and fiber. I'm mingled together to get the optimum balance ratio. And swelling because of the high water absorption. These are create more weak in mechanical and physical properties. These are the general problem I'm stated during my research. And my objective, there are three objectives to get back all the problems to find my new, what we call is a green material. All right, objective to evaluate the effect of the fiber loading. So I'm prefer for 10, 20, 30 and maximum 40 and treated with the sodium hydroxide alkaline treatment with and without to get the result for physical and mechanical properties. As I mentioned, that my research is more to the physical and mechanical. And the second, to investigate the fiber or fiber filler sizes. So I prefer 10 and 30 micron. That is 10 is my minimum small sizes and 30 is my bigger sizes. And the last one, to correlate between the fracture morphology of recycled polypropylene RPP and DBL, dried banana leaf campsite, observed via a scanning electron microscope observation with the effect of DBL loadings, DBL sizes, and alkaline treatment towards the result properties of RPP DBL-based campsite. And my research focusing scope is focusing on the, as I mentioned that, fiber loading from 0 to 40 of fiber DBL and the fiber sizes 10 and 30 micron. So you can see the picture A and picture B, how we using the industrial grinder to make it into the small particles, right? Fiber, and then we use for the treatment. We use I'm use sodium hydroxide, 6 gram of sodium hydroxide mixed with 1 liter, 1000 milliliter what we call is distillation water, heat up for 30 minutes at 50 degrees Celsius to process to split the content inside the fiber is lignin, hemicellulose, and cellulose, right? And then after that, we do some condensation process with the fiber and mix plastic and the fiber are mixed together in my own extrusion machine. I will show you later melting device, and to produce the what we call as a filament, material filament, composite filament, and then we crush it, and then using the injection molding to produce the dog bone sample according to ASTM D638 type 1. And the last is my research that the specimen, we go for the mechanicals such as a flexural, tensile, and impact test. And for the physical, for density, water absorption, and thickness swelling composite. All right. So based on the literature, what the past research has done, when it comes to the composite, I'm like to address here the plastic. Go for the thermoplastic, not thermoset, because thermoplastic is the recycled plastics. It's a recyclable, reuse and reduce compared to the thermoset. As we know, plastic is major plastic group is divided into the two, thermoset and thermoplastic. So myself, I'm focusing on thermoplastic. It's not in thermoset. And in fiber, we know that there's a few fibers using in agriculture. We can divide into 3 categories, main categories: cultivation, aquaculture, and poultry processing. So 3 different category in nature. Sorry. Okay. And based on that, in 2019, Malaysian Investment Development Agency, MIDA, have stated that in Malaysia, almost 2 million ton of agriculture waste are not utilized. So from there, I can get the picture how we can reuse the agriculture waste and the waste from the plastic to combine to produce a new material that can apply, especially during this pandemic. We produce a degradable plastic apron for frontliners and at the same time product for the automotive. So there we can see the characterization of nature fiber. As we know, there's three categories: particulate type, fibrous type, and laminate type. So my research, I'm focusing on fibrous type. So here I want to state just a mechanical analysis that what the previous researchers have done with the fiber and the plastic. So you can see here all the result for the mechanical analysis, all the tensile strengths improve when composite material between the plastic and fiber. And this part I'm going to address about the researchers have done few research on plastic and fiber with the leaf type of nature fibers, such as Kasim, Sutmo, Madhukiran, Mohanty, Prabhu, all address about the pineapple, such as pineapple leaf, banana leaf, date plum leaf. All the result, the finding, we can see everything, every result getting the tremendous strength in flexural, in tensile, and of course in impact energy. So from that, my research, I just conclude research gap. From the research gap, I get an idea, application of leaf type fiber. The second part, how the challenges, how the previous researchers, academicians prepare their sample, how they characterize, how they modified, how they treated the fiber or plastics, and how they develop the sampling, and what are the industry involved for this kind of the application. Of course, we know plastic is a low cost and fiber reduce manufacturing cost. That will be give the big impact to the manufacturing industry. So now I'm going to show you the methodology of my research. So I can divide into the two parts. First, start button, recycle polypropylene. So start from 100%, 60 until 60%. So this is a recycled plastic. What the next step? Next step, I'm crushing using the industrial crusher. And this part in my right hand side, we can see the dried banana leaf, the brown color. Okay, I'm grinding using the industrial grinder for this loading ratio. 10, 20, 30, and 40%. So these are, you can see there are my three objectives that I mentioned previously is dotted in the green, red, and blue. This is my first objective, prepare. Second is analyze effect fiber filler sizes and to correlate the fracture morphology. So this is my process, mixing preparation using my own melting device, my extrusion. I'm developed by my own, and the grinding after the filament, I'm grinding using the crusher, and all the grinding material we apply in the injection molding that in my laboratory to produce the dumbbell sample according to the ASTM D638 type 1. And the second objective, start for the testing to confirm it either my what we call is a powder, DBL powder is according to the size 10 to 30 micron, and start for the mechanical analyze. Using this one, I'm using the Fourier transform infrared, and morphological observation, I'm using scanning electron microscope. For the tensile test, we're using a universal testing method, universal testing machine, brand Gotek, from Taiwan. And the last part is SEM observation, result, data analysis, and conclusion of my full methodology. So now I'm going to discuss about my result. The first thing about the particle size analyzer PSA. So I mentioned about my what we call is dried banana leaf. I prefer for 10 and 30 micron. So using particle size analyzer, so I can confirm here the peak, the range of the particle from 0 to 35 micron. But we can see there is a peak at the 18% for the 10 micron. This red represent for the 10 micron and green represent for 30 micron. So here we can see the range between 10 and 30 micron almost captured 50 to 60% of the particle size, and the others are the depend on the sizes. And the second analysis to confirm whether my particle is belong to these sizes or not. So they are the scanning electron microscope. We can see there's an average value of the 10 micron sizes. These are 6 samples that I'm display here. Start from 9.6 until 14.6. So the average we get almost 10.4 micron. And for the 30 micron, so using scanning electron microscope, so I can identify, I can define here the average almost 32.4 micron sizes. So these are the two analyses to prove that what I'm grinding using the industrial grinder is according to the sizes I need for my research. The next, okay, this one for FTR, Fourier transform infrared analysis. This one to identify that I mentioned my dried banana leaf, I'm using sodium hydroxide, alkaline treatment, sodium hydroxide, NaOH, for 30 minutes at 50 degrees Celsius to heat up 6 gram and 1000 milliliter to find whether my DBL is OH present or not. All right, the black color, you can see the black color is for untreated DBL fiber, and the red spectrum for the treated NOH DBL fiber. So we know that the range wave number 3000 to 2550 is asymmetric and symmetric, which means is the presence of the hemicellulose and cellulose. So both are the is identified, but this peak is different with the untreated. But for the 1500 wave number 2000, we can see the difference between the red spectrum and black spectrum. Black spectrum is don't have any strong peak compared to the red spectrum, which is recorded the presence of OH in between the number 1336. This is a strong peak, which is define that the OH is present in this DBL fiber. So next, I'm going to talk about the tensile strength between the 10 and 30 micron for untreated DBL fiber composites. So we can see there's I'm already mentioned, I'm go for the 10 big number for the loading because first my purpose to reduce the plastic application. The second, to utilize all the agriculture waste. So I need the big number of plastics and big number of fiber. So that's why I'm prefer for 10, 20, 30, and 40. Maybe all the audience or the participant, maybe you have a question. Why not I'm go for the small numbers, 2 or 5? Yeah, of course can. But for my industrial application, so I'm prefer for the big numbers of ratio. So here we can see the green and the blue. Green is represent for the 10 micron fiber sizes and 30 for the blue for the 30 micron fiber sizes. So from here, what we can identify the positive improvement. This one is the plain RPP, recycle, the sample, recycle and recycle polypropylene is not contained with any fiber. So this is just recorded tensile is 16.8 megapascal compared to the 10 micron fiber sizes, which is the record, the tensile is recorded 31.6 megapascal, which is a positive improvement 32.7. So from here, we can conclude that compared to the blue also, 30% fiber optimum loading actually for the both 10 and 30 micron untreated. I'm talking about the untreated. And now we see for the, how about the impact strength for sodium hydroxide treated. Okay, here is still in the mechanical properties, but different analysis for the impact. So we can see the green is represent for the NOH, sodium hydroxide, blue is for untreated, and the orange is for the plain recycle polypropylene. So the result I'm obtained from the analysis. Okay, for the 30 micron is the optimal. It's leading for the all fiber loading is 30%. But compared to the treated and untreated, treated is recorded 5.94 joule per centimeter square, which is the positive improvement almost 69.7% for the treated DBL fiber. All right. And next, for the thermal analysis, I'm using a differential scanning calorimetry. So you can see there's a three different peak. This one for the recycled polypropylene, plain polypropylene. And this is second part for the 30 micron fiber sizes. And the last part is 10 micron fiber sizes. Okay, here there's a two different dot line. This one for glass transition temperature, and this one for melting transition temperature. Right. For the recycled polypropylene, the glass transition temperature is started at 85.5. What is a glass transition temperature? Let me explain practically. Let's say you using a water, mineral water, and then you keep it in your car under the sunlight for the 2 or 3 hours. After that, you get in your car and you drink the water. What are the tastes? And you can smell it, the different in the water, and something is not feeling good for your when you drink the water, because it's a glass transition temperatures so already there. What is glass transition temperature? Is the first point from the solid state to the liquid state, which means the physically the bottle is be the same state, but is chemically is reacted, which means it's a release few gases into the water. That is we call is a glass transition temperature. It's still in the solid state, but some reaction is happen due to the heat surrounding the plastic bottle. That is a glass transition temperature. For the 30 micron, you can see the glass transition is still bit increased, 87.9. For the 10 micron, yeah, that is a proof. Another again, 89.25 degrees Celsius. And for this part, for the melting temperature, for the plastic recycled polypropylene, normally the peak at 160. We know polypropylene temperature start from 160 to 260. And when I'm adding with the composite, with the 30 micron fiber DBL, they started improvement. So under 62.7 for the starting melting point. But when come to the 10 micron fiber sizes, yeah, that is a quite improvement in the melting temperature that recorded at 175.88 degrees Celsius. I'm talking about just for the fiber, not about the effect of sodium hydroxide. So now we see how about the effect of sodium density analysis for the physical test of sodium hydroxide. All right. We see here density is a physical, so one of the physical tests for the plastics. So this is a RPP. It's recorded at 0.902 is a density compared to the effect of NOH. So the blue is untreated and the green is treated. So we can see there's a reduction, tremendous reduction in the density of plastic composite material. So for the green, 30% fiber loading is just recorded 0.9007 compared to the the recycled polypropylene, the density is 0.902. So which is proof 30% fiber loading with the treated fiber DBL will reduce the density of the plastics. And next, I'm going to discuss about the water uptake analysis. It's still in the physical analysis. So water uptake analysis, so still 10, 30 and recycled polypropylene. So for the water uptake analysis, the weight is 0.501 gram is standard for the 50 gram of the plastic, the sample. And when treated, untreated, the sizes of 10 and 30. So green is represent for the 10 and blue for the 30 micron. So still we can get the comparison of the composite material. From my research is reduced a bit, the weight reduced bit compared to the recycled polypropylene, right? So it's considered water is not water uptake. No water is going inside the sampling. That is the point, which means the material is reduced. The weight of the sample is reduced from 0.501 to 0.5. Okay, the next part is water uptake analysis effect of sodium hydroxide. So this is this result give me more confident about my research due to we know that the recycled polypropylene is recorded 0.501 compared to the treated with the sodium hydroxide is just recorded 0.482 is more reduction in my water uptake analysis. The weight is different compared to the 10 and compared to the untreated and recycled polypropylene. So this is if thickness swelling effect of fiber sizes for polypropylene 10 micron and 30 micron. So still there's some few difference in the thickness swelling due to the recycled polypropylene is just recorded 0.17% compared to the untreated 10 micron and 30 micron. 30 micron for the fiber loading, 30% fiber loading. 10 micron is just recorded 0.27, bit higher from the recycled polypropylene compared to the untreated is recorded 0.37. So slightly this thickness keep increased due to the higher fiber loading in green composite, but slightly drop after increase in fiber loading. Okay, last of my analysis, thickness swelling effect of NOH. So now we consider this still remain in 0.17, but for the treated fiber compared to the untreated is recorded 0.27, but for the treated one is bit reduced and more similar to the recycle. Probably there still has a swelling, but it's not big as untreated. There's a when we compare sodium hydroxide is very effective for this analysis thickness swelling for the water or waterproof application of this material, composite material. And the last part of my analysis using scanning electron microscope fracture morphology. So effect of fiber sizes or the first picture is discuss about the recycled polypropylene. You can see there's still have voids. Even it's a recycled polypropylene because of the process and thermal during the secondary process will occur the voids in the structure of the polymer. And the difference of 10 and 30 micron. Yeah, they still have the voids for the fiber sizes, but you can see there's a boundary between the plastic and fiber. So they almost interfacial bonding is almost excellent compared to the 30% of 30 micron fiber sizes. So poor interfacial bonding, fiber pull out, a lot of voids there. So it become easily brittle or easily absorb the water apply this material for the waterproof or water application. All right. This is some my international and collaboration with NASA itself, with industry. A few pictures I want to share. And this is my laboratory. So we're producing apron, blown film for the frontliners in Malaysia. And these are the product that we supply to the Ministry of Health in Malaysia for the frontliners. This is a apron, and we call it the isolation gown. So both are different product. And these are the few product that I'm using dried banana leaf for the automotive product. These are all the automotive product for under the Malaysian company Proton Berhad. So I'm using my degradable plastic banana and plastic polypropylene to inject using the injection molding for this internal part of the automotive application. So last part of my presentation, I just want to discuss about the NOH treatment, sodium hydroxide treatment and untreated. So you can see there's a difference between the treated and untreated. So less fiber pull out in the picture, excellent bonding between plastic and fiber, and continuous matrix is happen. Compared to the untreated, is a lot of internal porous in DBL fiber, and the voids is more voids and worst because of the poor interfacial bonding between the plastics and fiber. So what I can conclude here, so from my research, so I'm prepared for 0 to 40% fiber loading. So from my research, I can conclude here, the optimum of fiber loading is 30% for dried banana leaf, which is recorded 19.10 megapascal. And for untreated, it's actually for the untreated. For the treated, we can see there's a positive improvement, 169.04%, which is a tremendous result I obtained from my research. And the fiber sizes, between the fiber sizes 10 and 30 micron, yeah, we can go for the minimum, like a previous presenter, Dr. Rameshwar, is discuss about 2 micron fiber size. Yeah, I'm also maybe in future I'm going to be maybe go for the nano size of my DBL fiber. And my recommendation for all the researchers, all academicians, why not we go for the different material, not polypropylene. Maybe can go for the recycled high density polyethylene. Maybe for the chemical treatment, we replace sodium hydroxide with magnesium hydroxide for the high thermal resistant, purposely for the high thermal resistant application. And for the fiber, maybe in Malaysia, the highest fiber waste in palm oil leaf, almost 47% is highest now in Malaysia. So maybe my next research, maybe I'm go for the palm oil leaf. So this is my reference and my acknowledgement. Thank you so much for giving this opportunity to share my research, and thank you all.
Thank you so much, sir, for such a wonderful presentation and sharing with us the method of recycling the waste material, especially thermoplastic waste obtained during the teaching learning process. It's a high time we do the recycling of the non-biodegradable waste, and your research will definitely boost it at a greater scale, sir. Your efforts to prepare the biodegradable degradable parts of an injection propeller using banana leaves, it's wonderful, sir. Thank you, sir, for sharing your work in so much detail. Thanks a lot, sir. It was a wonderful session, sir. Thank you, sir.
Thank you so much.
Now I request Savita Kumari ma'am to introduce our third eminent speaker of the technical session, Dr. A.H. Mijin Yava, sir. Over to you, ma'am.
Thank you, ma'am. Once again, good afternoon, everyone. I am profoundly delighted to take an opportunity to introduce the speaker of third session, Professor Dr. A.H. Mijinyawa. Sir obtained his first degree from Bayero University, Kano, Nigeria. He completed his post-graduation in chemistry from Sharda University, Greater Noida. He was awarded a doctoral degree in chemistry from Sharda University. His current research area is development of materials for novel applications. Sir has published many research papers in national as well as international journals. Sir will be sharing his knowledge with us on the topic, a review on recent materials for mosquito control. We are very glad to have you with us, sir. I request you, sir, to continue with this session. Over to you, sir. Hello. Sir, Mijinyawa, sir.
Yes, ma'am, we'll have to wait. I guess sir is not able to join, maybe. So we'll just give a few minutes for his joining.
In the meanwhile, you can take questions, no? Someone had posted some question in the chat box.
Yes, ma'am. Yes, ma'am.
Yeah, because we have time, maybe I can ask a question to Dr. Karan personally. So thank you so much for very, very interesting, very nice lecture, Dr. Karan. Very, very nice to listen to you. So
Yes,
you
sir.
are located in Malaysia?
Yes, sir, exactly.
So there are many natural fiber-based composite materials works going on in Malaysia. So very nice to listen to you. I have a very, very short query.
Yes,
So
sir.
we want our tires, automobile tires, to be non-degradable, isn't it? So if it is biodegradable, then it is not useful. So while we are using banana fibers or any kind of natural fibers into the tire application, then it may happen that these may attract the living organisms, bacteria, and so on, and making it degradable. So how to control it? One question, and the second is you already presented the tire that you fabricated by applying banana fiber. So but in the tire there are different kind of rubbers. How do you make the lignocellulosic fibers compatible with the rubber? What is the compatibilizer? Thank you.
Sir, actually, okay. Actually, yeah, I'm understood. But my product actually for internal part, not for the tire, not for the rubber. Actually, plastic. That I'm show you the picture. Actually, it's the internal part for the inside the window, not for the tires. So at the moment, the research on the tire, yeah, I'm not going on that platform. Maybe is from your idea. Maybe we can discuss about the tires, implementation of rubber, plastic, and banana fiber to produce a new material, maybe new tire for the automotive application. I will keep touching with you, sir. Okay, sir. Thank you so much for the question.
Thank you so much.
Thank you.
रिपोर्टिंग करावं लागतं. 13 डिजिटचा ARN नंबर आहे. पोरांनी 4 डिजिट 5 डिजिट टाकलेले.
Hello. Hello, Abu Bakar. Hello.
Yes, sir.
Whether sir joined or not. Abu Bakar joined now, just now. Yes, yes, okay.
Sir, we cannot see him. He has not yet joined, sir.
No, join, sir, I had joined just
Yeah,
now.
okay.
Yes, Abu Bakar, Amisha.
Okay, thank you for joining us, sir. So I'm very much delighted to introduce you once again. So, sir, we welcome you for this particular international conference, and we are very glad to have you. So I request you to continue with the session. Hello, Mijinyawa, sir. Am I audible to you?
So we can't hear you.
Hello. Hello.
Hello. Sir has left the meet. I think there is some
No,
issue from his side.
someone is there. Na? No, actually, unmute them. Okay, unmute the sir so that he can speak. And hello, Adulukar. Kindly share your screen and start your presentation. Okay. Hello.
So,
Start your screen. Share the screen.
so please unmute yourself, please, and then Vijay Yava, sir. We, you need to unmute yourself, sir.
Share the screen. Hello, Abu Bakar. Unmute yourself. Hello. Unmute yourself. Hello, Abu Bakar. Unmute.
Hello.
Hello. Hello.
Sir, please unmute yourself.
Hello, Abu Bakar. Hello. You have share the screen and unmute. Hello. Hello, Abu Bakar. Unmute first.
Sir, please unmute yourself. We can't hear you.
Okay. Now unmute. Hello. Unmute. Hello. Abu Bakar. Unmute yourself. Voice is not clear. Hello.
So please go to Google Meet page and unmute yourself.
हेलो मैडम वो जो मुस्तफा सर को बोलो ना उनको अनम्यूट करो.
Sir, from here we cannot unmute him.
No, no, host can unmute, na?
Host. Mustafa sir.
Host can do.
No, ma'am. No options are coming from my side. Like I cannot unmute him. He has to do it by himself.
I guess sir will have to stop presenting, unmute, and then start presenting again.
Yes, sir. You can click on this third icon.
So the speaker.
Click on third icon next to raise hand option. Before that.
Abu Bakar sir, you can switch to the mid screen again. We can guide you.
As this is taking a little more time, sir, Narayanan sir, can we take the question? Two questions were put up in the chat box. So if you permit, can we take those questions?
Yes, ma'am. Please, ma'am.
Yes, sir. I'll first take the question asked by Umar Ahmed Garba.
Okay.
What is the most important feature to be looked for in these natural fibers when selecting for making biodegradable plastics?
Okay. Yeah. Thank you, ma'am, for the question. All right. Actually, that's I mentioned during my presentation. I'm go for the bigger amount of fiber and less amount of the plastic. That's why I'm go for the start from 0 until 40% of fiber and 100 to 60% of plastic, because I want to reduce the plastic pollution and the same time to utilize more fiber from the agriculture waste to apply in the manufacturing process. Now we know that composite at the moment in Malaysia, they're more preferred for the medical side, in automotive industry, in manufacturing industry, in construction, even for the, as we know that for your information, right now I'm doing my novel research on graphene face mask. So on that material also I'm include fiber, and the same time I'm added with the graphene material and the plastic polyester to produce a new graphene face mask. Is under my research. Is already in the market in Malaysia. We already supply. So that is I'm telling that is depend on the how we going to utilize fiber and the plastics. So from my industrial side, we prefer less to reduce the plastics and more fiber to include in my composite material. Thanks for the question, ma'am. So for the question, it depends on the researchers how they going to use the fiber loading for their research and where its application. So my application mostly for medical side and the automotive. So it's depend on the application, madam.
Thank you so much, sir, for answering that question. I hope.
Yeah.
Okay.
Yeah.
Thank you.
I think sir is having technical issues, so we can break for lunch and can have presentation session after that. You can announce.
Okay, ma'am. Okay, ma'am. Ma'am,
Yeah.
there are two more questions which are to be taken.
Yeah, yeah. Question answers we can take.
Okay.
Yeah, after that.
Okay, ma'am. I'll do that, ma'am. Thank you, ma'am. Yeah. So one more question is there.
Yes, ma'am.
This question was put up on the YouTube. What about the bacterial susceptibility?
Sorry?
What about the bacterial susceptibility? So this is a question asked from one of the participants who are watching from the YouTube link, sir.
Okay. So is it the question more to the fiber or the plastics? I'm not clear about the question.
So that's only a question asked about the bacteria. So there's one more question. We'll take up this question from Mr. Satish Patil. Bacterial polymers, cellulose, is also versatile polymer. Is it possible to replace instead of banana fiber?
Yes, ma'am. Any fiber we can replace, but purposely I'm choose for the banana leaf. That is some few environmental impact from the banana leaf that I mentioned earlier. Emits 20% of methane gas and contribute to the global warming. So that is my intention, my innovative of composite material. So they can prefer any kind of fiber. They can combine with any plastics, not only thermoplastic. They can combine with the thermoset to produce any composite material. So no doubt about it.
Okay, thank you so much, sir, for answering all these questions. Thanks a lot, sir.
Thank you, ma'am.
Yeah. So as ma'am said, because of the technical issues, we cannot continue with the third session. We'll break now for lunch, and we'll rejoin in, ma'am, say like 30 minutes. We'll rejoin.
Yeah, whatever time we have mentioned in the schedule, 3 or 3:15, 3 o'clock, no? Presentation session.
Presentation we had from ma'am 2:30. So we'll start with the presentation.
3 o'clock.
3 o'clock. Okay.
Yeah.
Okay. So we'll start with the presentations at 3 o'clock. We can break for lunch now. Okay. Thanks a lot. I thank all the both our eminent speakers for their wonderful talk, and it was really enlightening and enriching, sir. Thanks a lot, sir. So let's break for lunch, and we'll start with the presentation within half an hour. Okay. Thanks a lot.
And thank you, everyone.
Hello, sir. Am I audible?
Yes, sir. You're audible, sir. So now, just because, yeah, yes, sir. We can hear you, sir. So,
Okay.
so give me 2 minutes, sir. I'll let you know what is to be done now. So give me 2 minutes.
Okay, madam. I didn't hear you. Hello, madam. Am I audible?
Yes, sir. Yes, sir. You're audible, sir. It's just that you were not able to reconnect, sir. We have announced the lunch break now, sir, because it is already 2:30.
Okay.
Yes, sir. We were supposed to finish with it at 2:30. So we have taken a break now for lunch break. But, sir, since you have joined, I will let you know what is to be done, sir. Yeah? Just give me 2 minutes,
Sorry
sir.
for the inconvenience.
No
Thank you.
problem, sir. It's a network connectivity problem. We can understand, sir.
Okay,
Just give me a
thank you
minute,
very
sir.
much.
Yeah, yes, sir.
Thank you.
Hello. 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 Hello.
Hello. Yes, sir.
Hello, sir. Yes, sir. Sorry. Yes, sir.
Hello.
Sir,
Abu Bakar Sari joined now.
sir, he has joined now, but sir, we already announced for the break, so I was just.
Yes. After this break, now we will continue. Okay.
Okay, sir. Okay, sir.
Yes.
So,
Okay.
sir,
Yes.
will sir be able to join then after half an hour, sir? Again?
Yes. Half an hour. Yeah.
Okay, sir. Okay, sir. Thank you, sir.
Okay.
Hello.
Yes, sir. So give me time. Give me time. I'm not able to reach what has to be done. Can we continue with the session now or later? I need to take that confirmation, sir. That's why getting delayed, sir. Just give me 2 minutes.
Harshada ma'am, we can start after 10 minutes.
Sir, yes, sir. Can we take a 10 minutes break now and you can continue?
We can start at 2:40.
Yes, sir. It's 2:30 now.
2:30.
Okay, thank you, ma'am.
Yeah.
Yeah.
तुमचं Sir, shall I start?
Sir, actually, because of the technical problem, the third technical session was not able to, continue, sir. So, the speaker, the third technical session speaker, Dr. Mijinyawa, sir, he might join in some time now, sir. And so, please cooperate with us. And sorry for the inconvenience. Sarika ma'am, whatever you're saying, we couldn't hear you, ma'am.
Okay. Am I audible, ma'am?
Yes, ma'am, I can hear you now. Yes, ma'am.
Okay. Thank you.
Yeah.
Good afternoon once again. Now we are going to begin with oral and poster presentation. We couldn't, due to some technical issue, we couldn't have our third session, so that we'll be having later on. So we'll start with oral and poster presentation. I'm profusely overjoyed to introduce to you Principal Dr. Leena Sarkar, who will be chairing today's technical session of this international conference. Ma'am completed her PhD from University of Rajasthan. She has worked on BRNS project entitled Organometallic Chemistry of Platinum Group Metal Complexes with Heterophospholes, which was sanctioned by Department of Atomic Energy. She has presented posters and papers in various national and international conferences and published around 40 research papers in national and international journals. Ma'am is the life member of Association of Chemistry Teachers. She has organized international and national conferences, seminars, webinars, exhibitions, and took up different activities to promote science. She is the recognized research institute for MSc and PhD degree. Ma'am has received various awards such as Shikshak Shri Award, which was conferred by Antarashtriya Samarasta Manch for the work in field of education, Jesht Shikshak Samman by Maharashtra Seva Sangh, Vocational Excellence Award was given by Rotary Club of Linktown, HFF Award by Human First Foundation in 6th HFF Festival for Academic Contribution, Cassie Community Leader Award in appreciation of services to the society, Outstanding Contribution to Education Award by Golden Global Health and Education Awards, Excellence Award by JVM Trust, Excellence in Field of Education Training Award by Rotary Club, Outstanding Contribution in Education and Chemistry Award by Bellamy Golden Global Health and Education International Conference and Awards, Dubai, UAE. She was recognized as trainer for Global Student Solar Ambassadors Workshop, IIT Bombay, supported by UGC, and IYPT 2019 India Program Coordinator for IARC, UNESCO, ICUN. With this brief introduction of the chairperson of this technical session, we would like to felicitate ma'am with memento as token of appreciation and love. We welcome you, ma'am, for this technical session. Now we will start with the presentation session with to begin with a few instructions.
Thank you so much, Savita.
Yeah.
For detailed. Yeah, thank you. Thank you so much.
Yeah, you're welcome, ma'am. Maximum 5 minutes will be given for presentation. All presenters are requested to strictly adhere to given time limit. So with this, I call upon our first presenter, Mrs. Sarika Dutal, ma'am.
Thank you, ma'am. Is the screen is visible, ma'am?
Yeah, it is visible.
Okay. Good afternoon to all of you. First of all, I will welcome all in this JVM's Virtual International Conference on Multifunctional Advanced Material 2021. Myself, Dutal Sarika Ganpat. I am working as a student in SRTMU Nanded and I am a permanent lecturer in Government Polytechnic Nanded. Here, the topic of my oral representation is use of pyroxylene derivative as a precursor for synthesis of metal complexes of cobalt second and nickel second using mixed solvent media. Here, The introductory part of my presentation is I was decided to work up with this pyroxylene derivatives because there are so many applications related to this pyroxylene derivatives along with the metal complexes. The applications are for industrial purpose as well as for the pharmaceutical purpose. Just like they are used as a drugs in cancer therapies, they are used as a pigments or dyes, they are used as a paramagnetic MRI contrast agent, and they are having antibacterial characteristics. Therefore, they are used as antibacterial agents, and also they are used in organic photovoltaic materials. And therefore, I was chosen this topic, preparation of the ligands, and from that ligands, I was prepared the metal complex of that pyroxylene derivative. The methodology which was adopted by me, that methodology is categorized into three parts. Firstly, I was prepared the starting material for that pyroxylene derivative. These are nothing but unsaturated ketones, which are made up of acetone and aldehydes, substituted acetone and substituted aldehydes. Then afterwards, by using this starting material, I was prepared the ligand from pyroxylene derivatives from that alpha beta unsaturated ketone by using the mixed solvent system, that is ethanol and water in 9:1 proportion. And lastly, I was prepared the metal complexes from this ligand of pyroxylene derivative, the metal complexes of cobalt and nickel metal ion. In this way, the three steps are used: preparation of starting material, preparation of pyroxylene derivatives as a ligands in mixed solvent system, and third one is the preparation of the metal complexes. The first one, that is the preparation of the alpha beta unsaturated ketones. For this one, this is the normal procedure for preparation of the starting material. The substituted acetophenone and substituted benzaldehydes, they are mixed, and here NaOH is alkaline media is used, and from that one, the starting material, that is chalcones or alpha beta unsaturated ketones, were prepared. And this starting material which was used for the preparation of the pyroxylene derivatives. Here, the next one. These are the three chalcones or alpha beta unsaturated ketone which was prepared by the substituted acetophenone and substituted aldehydes by bromoacetophenone, 4 bromoacetophenone and 4 chloroaldehydes. In this way, these are the list of the alpha beta unsaturated ketones which are used as a starting material for the pyroxylene derivatives. Here, the next one, this synthesis of pyroxylene derivative by using the mixed solvent system, ethanol and water. For this one, I was taken here 4 millimoles of alpha beta unsaturated ketone and 28 millimoles of hydrogen hydrate, and that is mixed into 20 ml of mixture of ethanol and water. That ethanol and water, it is taken into 9:1 proportion in the round bottom flask, and that flask will be refluxed for 5 to 6 hours up to the product will be come. And after coming that product will be kept overnight, and in the second day the product was observed inside that round bottom flask, and it will be recrystallized by using the pure ethanol, and then that product is filtered, dried properly, and that product was used for the preparation of the metal complexes. This is my ligand, pyroxylene derivative. These are nothing but the list of ligands which was prepared. Here 3,4 bromophenyl, 5,4 chlorophenyl, 4,5 dihydro 1 pyrazole. Here these are nothing but the 3 ligands which was prepared, and these ligands are confirmed with the help of this spectra, NMR spectra, which was taken by Safe Chandigarh, Punjab University, which clearly indicates that there is the preparation of the pyroxylene derivatives. These 3 hydrogens which are indicated here, these 3 hydrogens, H1, H2, H3, for this doublet of doublet is observed, which clearly indicates the preparation of the pyroxylene, and that pyroxylene which is acting as a ligand, and that will be used for the preparation of the metal complexes. For the preparation of the metal complexes, here the solution of that metal salt and ligand, that will be taken in 1:2 proportion. Here 2 millimoles of ligand firstly dissolved into 9:1 ethanol and water. 10 ml of that ethanol and water is taken into round bottom flask, and that will be stirred continuously on the magnetic stirrer. After complete dissolution of that ligand, the 1 millimole of metal salt which was added into that round bottom flask, and that will be stirred for overnight, and the precipitate was observed, and that precipitate was filtered, washed with excess of ethanol, and that was dried, and there is the preparation of the metal complexes. Here I was shown here the two metal complexes which are prepared from this L2 ligand. This L2, it is related to this one, 3,4-bromophenyl, 5,4-chlorophenyl, 4,5-dihydro-1-pyrazole. From that one, these metal complexes were prepared, which is having peach color. One is of cobalt and other is of nickel. In this way, for L3 and L4 ligand, the same, by using cobalt and nickel, the same metal complexes were prepared. Here, the presence of OH group, which is observed with the help of this peak, and there are the bonding between the nickel and nitrogen, and nickel and simply nitrogen, double bond and single bond, and oxygen bond is formed, which is obtained by using this IR spectra, which was taken from IIT Bombay. And here the TGS spectra, which indicates that there is the decrease in weight 2 times, and therefore that will be acting as a bidentate ligand, and therefore whatever the list of metal complexes which are prepared, this list of metal complexes, this pyrazolene behaved bidentate ligands towards the cobalt and nickel, they are prepared, and these metal complexes are having octahedral symmetry, which is having the molecular formula ML2H2O twice. Thank you so much.
Any question from participants? Okay, since there are no questions, so we will continue with the next presenter. Before that, I would like to announce that we will be presenting the screen, your PPT, we will be sharing it. You just have to speak, okay? So, yeah.
Okay,
so, ma'am, can you please stop sharing your screen? Yeah,
Okay,
thank you.
तिने मध्ये बिलकुल थांबवलं नाही.
मला
कसं झालं मॅडम?
So our next presenter is Dr. Ravin Jugade, sir. So you.
Yes, thank you very much. A very good afternoon. Am I audible, madam?
Yes, sir, you are audible.
Okay. Thank you very much. Very good afternoon, one and all present over here. This is Dr. Ravin Jugade, and I'm going to present the work by one of my students, Sanjeevani Korde, on elimination of chromate ions from aqueous solution using mesoporous chitosan zirconia magnetic composite. In the morning, Dr. Adhikari talked about chitosan as a biopolymer, which is extremely important, and it is second largest available biopolymer in nature after cellulose, and that can be used as an adsorbent for removal of various toxic metals as well as some organic components or organic compounds which are present in the nature as pollutants. In this work, we are going to discuss about the chromate ions removal. Now, this chromium-6 is known as a carcinogen, and it harms the atmosphere to a great extent when it comes from various electroplating industries. The work which has been allotted to me is actually the role of chitosan as a magnetic composite and preparation of magnetic composite with zirconia. Now, this chitosan is having the functional groups like NH2. Sorry, madam, if you can keep the slide in as per my requisition, please. Yes, thank you very much. So this pollutant is chromium-6, which is a carcinogen, and the adsorbent which we are proposing is the chitosan zirconia magnetite composite, which we are representing as CHZrFe composite, which is a magnetic material. Now, this chitosan is having the functional groups like NH2 and OH, which can be used for modification of this material or this biopolymer. Next, please. Next slide, please. The synthesis material or synthesis procedure involves the addition of ferrous chloride and ferric chloride solutions, followed by zirconium oxychloride. Next, please. Followed by addition of 1% chitosan solution in 1% acetic acid, and continuously stirring the solution for half an hour with the help of a magnetic stirrer. And when the solution is completely homogenized, we added 2 molar NaOH in the dropwise manner into the solution. Next, please. When NaOH is added to the solution, next, please, we get the precipitate formation of the composite. The precipitate is settled at the bottom. It is allowed to settle, and the precipitate is formed, which is magnetic in nature. This we call as CHZrFe composite. Since it is magnetic, it will be attracted towards the bar magnet. Next, please. A typical adsorption study includes the taking of 50 mg per liter of chromium solution, and to that chromium solution 100 milligram of this meso CHZrFe material was added. It was stirred on magnetic stirrer for desired period, and then the solution was decanted by taking the help of this circular bar magnet which is kept at the bottom of the conical flask. Now, since the material is magnetic in nature, just decanting it will remove the we can remove the solution, and the adsorbent remains at the bottom of this conical flask. Next, please. The material which was synthesized was next slide, please, was characterized by various techniques, including the FTIR. If you see the FTIR spectrum of chitosan and CHZrFe, you will see that there are 2 important peaks of FeO band at 750 nanometers. And next, please. And another band of ZRO at 590 nanometer. So these 2 bands clearly indicate the formation of this composite of chitosan with zirconia and Fe3O4. The pH PZC of this material was found to be around 7.3, indicating that the material is having positive surface charge below pH 7.3 and negative charge above pH 7.3. Next, please. The material was characterized by SEM and EDX. The same spectrum shows a typical morphology of porous material, and the EDX spectrum, we can see that clearly zirconium and Fe peaks in the material, indicating clear formation of the composite, and a peak of fluoride was observed even in the after adsorption of the material. Next, please. Next, please. The material was characterized by BET surface area analysis, TGA, DTA, and XRD. Now, it can be seen from the BET curve of nitrogen adsorption desorption. We can see that the material is mesoporous in nature. Next, please. With a large surface area. Please back. Previous one, madam. The surface area of the material was 109 square meter per gram, which is a large surface area with a pore volume of 1.4 cubic meter per gram. It clearly indicates the material is mesoporous in nature. The XRD pattern clearly showed all the peaks corresponding to Fe3O4 as well as ZRO2. Next one. The operating parameters were optimized by varying the pH, adsorbent dose, contact time, and concentration of the chromium 6 solution. Next, please. The pH was optimized at 3 because the highest adsorption capacity was found at pH 3. Next, please. The adsorbent dose was optimized at 100 milligrams as shown over here. The contact time of 60 minutes. Next, please. 60 minutes was optimized as an equilibrium is reached in 60 minutes, whereas the concentration of chromium 6 was taken as, next please, 50 ppm, because After that, there is a reduction in the adsorption efficiency. Next one. Next one. The Langmuir and Freundlich adsorption isotherm and pseudo first order, pseudo second order kinetic models were studied. It was observed that Freundlich model is followed, indicating that the adsorption process is on the heterogeneous surface with a multi-layer adsorption, and pseudo second order kinetics was followed, indicating that the chemisorption type of phenomena. Next one. Next, please. Yes. The overall conclusion of the method is the material has a pH PZC of about 7.6, optimum pH of 3, contact time of 60 minutes was sufficient, the concentration of chromium which was used was 50 ppm, adsorbent dose was 100 milligrams, and isotherm followed by Freundlich. Kinetics followed is the pseudo second order kinetics. The method was found to be, or the adsorption was found to be spontaneous as indicated by the values of delta G. And the adsorption capacity of the material is very good, which is 77 milligrams per gram. Next, please. Next, please. Thank you. Thank you very much for your patience hearing. Thank you.
Thank you, sir. Any question from participants? Okay, so since there are no questions, so we will continue with next presenter, Mr. Sanjeev Kumar Rahangdale. Sanjeev Kumar, sir.
Yes, ma'am.
Yeah, sir, I have presented your PPT. You can start.
Am I audible, madam?
Yes, sir.
Good afternoon to all of you. My topic is removal of toxic metals, ions from wastewater using orthotoluidine melamine formaldehyde polymeric resin. Here, copolymer is a large molecule composed of repeating structural units, typically connected by covalent chemical bond. Copolymer have played an important role from the beginning of life. Here, synthesis of TMF copolymers. The TMF copolymer was prepared by condensing orthotoluidine and melamine with formaldehyde in the presence of 2 molar HCl as a catalyst at 122 degrees Celsius in an oil bath for 5 hours. The cream-colored polymer obtained was washed with hot water and finally with ether to remove excess of acid monomer. It was further purified by dissolving in 10% NaOH and then filtered. The copolymer was then reprecipitated by drop-wise addition of 1:1 concentrated HCl and water with constant stirring and filtered. The method was repeated thrice. The resulting polymer sample was washed with boiling water and dried in a vacuum at room temperature. The purified copolymer was finely ground to pass through 300 mesh sieve and kept in vacuum over silica gel. The yield of the copolymer was found to be about 82%. Then here, use various techniques for characterization analysis of copolymer. The copolymer resin were subjected to elemental analysis for carbon, hydrogen, and nitrogen. Then electron spectra of the copolymer in DMS were recorded. Then infrared spectra of TMF copolymers were recorded. And fourth one is the proton NMR spectra were recorded. Here, this is the application part, ion exchange properties. The ion exchange properties of TMF copolymer resin were determined by the batch equilibrium method. Here, from this study, with 5 metal ions under limited variations of experimental conditions, certain generalization may be made about the behavior of the copolymer sample. Here, effect of electrolytes on metal uptake, the copolymer sample 25 milligram was suspended in an electrolytic solution, that is 25 ml of known concentration. The pH of suspension was adjusted to the required value by using 0.1 molar NaOH. Then the suspension was stirred for a period of 24 hours at 25 degrees Celsius. To this suspension, 2 ml of 0.1 molar solution of metal ion was added and the pH was adjusted to the required value. The mixture was again stirred at 25 degrees Celsius for 24 hours and filtered. The copolymer was washed and the filtrate and washing were combined and estimated for metal ion content by titration against standard ethylene diamine tetraacetic acid. A blank experiment was also carried out in the same manner without adding the polymer sample. The blank was again estimated for the metal ion content. The amount of metal ion taken up by the polymer in the presence of the given electrolyte of known concentrations results from the difference between the blank reading and the reading in the actual experiment. The effect of electrolytes, here sodium nitrate, NaCl, and sodium perchlorate, here sodium sulfate. Here these studies was estimated at pH 5.5 for copper, nickel, cobalt and zinc, and at pH 3 for Fe, using 4 different electrolytes with 5 different concentrations of each. We examined the influence of chlorate, nitrate, chloride, sulfate at various concentrations on the equilibrium of metal-resin interaction. Here figure shows the amount of metal ion taken up by the given amount of copolymer depends on the nature and concentration of the electrolyte present in the solution. In the presence of perchlorate, chloride and nitrate ion, the uptake of Fe, copper and nickel ions increases with increasing concentration of electrolyte, whereas in the presence of sulfate ion, the amount of the above mentioned ion taken up by the copolymer decreases with increasing concentration of the electrolyte. Here the uptake of cobalt and zinc ions increases with decreasing concentration of chloride, nitrate, perchlorate and sulfate ions. This may explain on the stability constant of the complexes with those metal ions. Here, rate of metal ion uptake to estimate the time required to reach the state of equilibrium under the given experimental conditions. A series of experiments of the type described above were carried out, in which the metal ion taken up by the chelating resins were estimated from time to time at 25 degrees Celsius, that is in presence of 25 ml 1 molar sodium nitrate solution. It was assumed that under the given condition, the state of equilibrium was established within 24 hours. Then the rate of metal uptake is expressed as percentage of the amount of metal ion taken up after certain time related to that in the state of equilibrium. The rate of metal absorption was determined to find out the shortest period of time for which equilibrium could be carried out while operating as close to equilibrium condition as possible. Here figure shows the dependence of the rate of metal ion uptake on the nature of the metal. The rate refers to the change in the concentration of the metal ions in the aqueous solution which is in contact with the given polymer. The results show that the time taken for the uptake of the different metal ions at a given stage depends on the nature of the metal ion under given condition. It is found that ferric ions require about 3 hours for the establishment of the equilibrium, whereas copper, nickel, cobalt, zinc ions require about 5 hours. Thus, the rate of metal ion uptake follows the order Fe3 positive is greater than copper, then nickel is greater than also cobalt and is equal to zinc for EMF copolymer. Then here distribution ratio of metal ion at different pH. Here the distribution of each one of the 5 metal ions, that is Fe, copper, nickel, cobalt, zinc, between the polymer phase and aqueous phase was estimated at 25 degrees Celsius, and in the presence of 1 molar sodium nitrate solution, the experiment were carried out at different pH value. Here distribution ratio can be calculated by the ratio of weight of metal ion taken up by 1 gram of polymer and weight of metal ion present in 1 ml of solution. Here the effect of pH on the amount of metal ion distributed between two phases can be explained by the result given in the figure. The data on the distribution ratio as a function of pH indicate that the relative amount of metal ion taken up by the TMF copolymer increases with increasing pH of the medium. The TMF copolymer resin takes up Fe3 positive ions more selectively than any other metal ions under study. The order of distribution ratio of metal ion measured in the pH range 2.5 to 6.5 is found to be Fe3 positive is greater than copper 2 positive and also greater than nickel, cobalt and zinc in this increasing order, and thus the result of such type of study are helpful in selecting the optimum pH for selective uptake of a particular metal cation from a mixture of different metal ions. For example, the result suggests the optimum pH 6 for the separation of cobalt and nickel. With a distribution ratio, the value of D is 47.1 and 13 to 4.1 for cobalt and nickel. Similarly, for the separation of copper and Fe, the optimum pH is 2.5, at which the distribution ratio D for copper is 66.1 and that for Fe is 5 to 2.1. The lowering in the distribution ratio of Fe was found to be small and hence efficient separation could be achieved. And here the copolymer TMF based on the condensation reaction, and then TMF is selective selecting ion exchange polymer for certain metals, and the copolymer showed a higher selectivity for copper and Fe ions than for cobalt, nickel and zinc ions. And thank you.
Thank you, sir, for your wonderful presentation. Our next presenter is Dr. Dhondiram Sakhare, sir. Sakhare, sir. I think sir is not there in the meet. Next presenter is Yash Pal Rathore, sir.
Yes, ma'am. Yes, I'm there.
Okay,
Hello?
sir. Sir, I'll present your PPT and
Okay,
then you
ma'am.
can start.
Okay, ma'am. Yes. Good afternoon to one and all present over here. I am Yashpal Rathod, doing research under the supervision of Dr. W.B. Guroli, sir. My topic of presentation is synthesis, spectral morphology of copolymers and its photoluminescence studies. Next, please, ma'am. Hello. The outline of presentations are introduction, experimental results and discussion, photoluminescence properties, summary and conclusion. Next, please, ma'am. In introduction, we will see some basic terms about the polymer and copolymer. Polymer is nothing but a large molecule composed of repeating structural unit. Typically, they are connected by covalent chemical bond. What is monomer? Monomer is nothing but the smallest repeating unit or building blocks of polymer. Then our main point is copolymer. What is copolymer? Copolymer is the polymer which is composed of two or more different repeating subunits or monomers. And then polymerization, the process of reacting monomer molecule together to form polymer is called as polymerization. Next, please, ma'am. Next slide. Then next point is experimental, how the copolymer is synthesized. In the synthesis of copolymer, we have taken 0.1 mole of this monomer 8 hydroxyquinone 5 sulfonic acid, 0.1 molar of phthalic acid, and 0.2 molar of formaldehyde, which is in the presence of 2 molar acid catalyst in an oil bath, which is reflects for 5 hours. And after the completion of reaction, the yellow solid product is obtained as a copolymer, which is purified by recrystallization with diethyl ether, ethanol, etc. The purified copolymer is kept overnight in a silica gel. Next, please, ma'am. Then result and discussion. Next slide, ma'am. After preparing this copolymer, we are characterize this copolymer. First one is elemental analysis. The elemental analysis of copolymer has been analyzed for its carbon, hydrogen, nitrogen, and sulfur content. And on the basis of this data obtained, we can say that the empirical formula and empirical formula weight is found to be C20, S17, N, O8, and S, whereas empirical formula weight is 431 and 40. The elemental analysis is carried out from stick coaching, where the observed value and calculated value are in good agreement with each other. Then next characterization technique, we have used the FTIR spectroscopy. Here it can be seen that the broad spectrum obtained at 3508 is due to OH stretching frequency, which is present in the copolymer. Then the characteristic band, which is obtained at 1620, is due to the carbonyl group, which is present in the copolymer resin. Then the band displayed at 1199 to 1228 per centimeter suggests that the presence of methylene bridges the polymer. Next, ma'am, please. Hello, there are some sounds are there.
Ravin sir, can you please mute yourself? Ravin sir. Ravin sir, Mustafa sir, can you please mute Ravin sir?
कसं आहे की तिथे आम्हाला तिथे काम करत असताना
Ravin sir, can you please mute yourself? Ravin sir.
Okay.
Yes, sir, you can continue now.
Sorry for inconvenience. Then this copolymer is characterized by H1 NMR spectroscopy. Here we can see that the sharp signal obtained at 2.5 due to methylene bridge, which is present in the copolymer. Then there are some multiplates which is shown over here. In between the chemical shift value 7 to 8 ppm is due to the presence of aromatic proton. Then there is a presence of the sharp signal at 9.09 is due to the presence of a phenolic hydroxyl group, which is present in COH carboxylic acid group. And the last singlet, which is shown over here, 9.80, is due to the sulfonic acid group. Next, please, ma'am. Then our main interest is to study the photoluminescence properties of this copolymer. Next, please, ma'am. Hello. Before going to the photoluminescence, we have to see some basic term involved in this. What is luminescence is nothing but the spontaneous emission of light by a substance. It occurs when an electron returns to ground state from excited state and loses its excess energy as a photon. There are certain types of luminescence. First one is phosphorescence. Phosphorescence is nothing but absorption and slow re-emission of light. whereas fluorescence is vice versa, like phosphorescence. Fluorescence is nothing but absorption and fast re-emission of light. The next type of luminescence is chemoluminescence, where source of energy to excite molecule is chemical reaction. Right. Next, please, ma'am. Here there is a spectroscopy is used because it is a powerful optical method used for the characterizing the materials. It can be used to find out the impurities and defects in silicon and group 8 elements semiconductors. It also used to determine semiconductor band gaps. It can be also used as a material absorb light, creating electron hole pair, and electron from the valence band it jumps to the conduction band, leaving a hole. These are the important of photoluminescence study. Next, please, ma'am. Next slide, please. Here we studied the photoluminescence spectra of this copolymer at HQ5SAPF copolymer by using this instrument in Kamla Nehru Mahavidyalaya, Nagpur. This at HQ5SA PF first, where there is a print mistake. Copolymer shows the excitation at 324 nanometer. It shows the excitation as at 324 nanometer. It gives two emission bands. One emission band at 380 nanometer and other at 401 nanometer in the UV visible range, along with blue emission. The peak at 401 nanometer is more intense as compared to the other peak that is obtained at 380 nanometer. The intensity of peak found to be 565.56 angstrom. Next, please, ma'am. Next slide. Next point is summary and conclusion. In summary and conclusion, we can conclude that a new copolymer at HQ5SAPF first based on condensation reaction of 8-hydroxyquinone 5-sulfonic acid and phthalic acid with formaldehyde in the presence of acid catalyst has been prepared. On the basis of spectral and physiochemical analysis, the structure have been suggested for newly synthesized copolymer. The newly synthesized copolymer, that is 8HQ5SAPF first copolymer, shows high photoluminescence properties. The photoluminescence study of this copolymer shows that the prepared material has some quality to be utilized in the research of semiconductor gadgets as well as in light emitting materials. Next, please, ma'am. Thank you for your patient listening.
Thank you, sir. Our next presenter is Mr. Narayan Das, sir.
Yes, madam.
Sir, I am sharing your presentation. You can start.
Yes, madam. Thank you, madam. Good afternoon to everybody. Myself, MC Das.
Yashpal sir, can you please mute yourself? Yashpal sir. Mustafa sir, please, can you please mute Yashpal sir?
Good afternoon to everybody. Myself, MC Das, Department of Chemistry, Dr. Ambedkar College, Chandrapur. My topic of presentation is
Yashpal sir. Yashpal sir. Can you please mute yourself, Yashpal sir?
My topic of presentation is semiconducting properties of organic copolymer synthesized from 2-hydroxy 4-methoxybenzophenone and 1,5
diaminonaphthalene under the supervision of Honorable Dr. W.B. Gurundale sir, Professor, Department of Chemistry, Kamla Nehru Mahavidyalaya, Nagpur. Next, please, madam. Introduction. The polymer. A polymer is a large molecule or macromolecule made up of many number of repeating units. Here, ethylene is the small molecule. When many number of ethylene molecules are joined together, the large molecule form that is called the polymer. Next, please, madam. Next, madam. Next slide, madam. Classification of polymers. Based on origin of source, polymers are classified as natural polymers, semi-synthetic polymers, synthetic polymers. Based on structure, they are classified linear polymers, branched chain polymers, cross-linked polymers. Based on molecular force, they are classified as elastomers, fibers, thermoplastics, thermosettings. Next, please, madam. Next, please, madam. Next slide, madam.
Sir, I'm changing. There is a time lag, so it's taking time to show that slide. Yeah.
Polymerization, that is, there are two types. It is the addition polymerization and condensation polymerization. Addition polymerization proceeds through free radical ionic coordination polymerization. Again, ionic polymerization, it proceeds through cationic polymerization and anionic polymerization. Next, please, madam. Application of polymers. Polymers find application in printing and packaging, electronic and data storage, energy, textile, healthcare and life sciences, automotive, aerospace, and nearly all aspects of our life. Next, please, madam. Experiments and experimental techniques. The monomer used for the preparation of the copolymer is 2-hydroxy-4-methoxybenzophenone, 1,5-diaminonaphthalene, and formaldehyde. Next, madam. Synthesis of copolymers. By using 2-hydroxy-4-methoxybenzophenone, 1,5-diaminoaphthalene, and formaldehyde, I have prepared the 4 copolymers, first, second, third, and fourth, in the molar ratio of 1:1:2, 2:1:3, 3:1:5, 4:1:5. Next, please. Synthesis of copolymer. Copolymer are synthesized by condensing 2-hydroxy-4-methoxybenzophenone, 1,5-diaminoaphthalene, the formaldehyde, in the different molar ratio of the monomers in the presence of 2 molar HCl at 126 degrees centigrade at about on heating 4 to 5 hours. The brown colored solid product was obtained, and it was then purified by dissolving in 8% sodium hydroxide solution. Next, madam. Next, please. This is the data of the preparations of the 4 copolymers. So, 4 copolymers, the copolymer first, the yield of that copolymer first it is found to be 82%, and melting point is 432. Copolymer second, the yield is found to be 85%, and melting point is 438 Kelvin. And copolymer third, it is the yield is found to be 84%, and the melting point is 445. And fourth copolymer, the yield is found to be 81%, and melting point is 450 Kelvin. Next, please, madam. The solubility of the copolymer agents. The solubility of the copolymer resins is found to be soluble in sodium hydroxide solution, dimethyl sulfoxide, dimethyl formamide, and potassium hydroxide. They are insoluble in acetone, benzene, chloroform, the carbon tetrachloride. They are partially insoluble in carbon disulfide and this is the pyridine. Next, please, madam. experiments and analytical techniques that is used for the characterization of the copolymer, that is the elemental analysis, non-aqueous conductometric titration, UV visible spectra, FTIR spectra, proton NMR spectra, carbon-13 NMR spectra, scanning electron microscopy, and electrical conductivity. Next, please. Elemental analysis. From that elemental analysis, the elemental analysis is carried out to for the determinations of the molecular empirical formula and the molecular formula of the repeating units. From that elemental analysis, the percentage of the carbon for the copolymer, first it is 0.7 to 1.62. The percentage of the hydrogen, it is 0.6.50. Percent of hydrogen, it is the 9.25, and percentage of the oxygen, it is the 13.28. On the basis, the empirical formula of the repeating unit, it is the C21 H20 N2O3, and the empirical formula of it is the 348. And similarly for the copolymer second, third, and fourth. Next, please, madam. The number average molecular weight by the non-aqueous conductometric titration. Next, please. These are the specific conductance for the copolymer first, second, third, and fourth. This is noted by the addition of the milli equivalent of the base added. Next, please. This is the conductometric titration curve. So this graph is plotted between the milli equivalent of the base per 100 gram of copolymer against a specific conductance. In the curve, there are the several breaks are obtained. From that breaks, the molecular weight of the copolymer is evaluated. Next, please. The molecular weight of the copolymer, first it is found to be 2320 for polycopolymer. Second, it is found to be 2893. For the third, it is found to be 3238. For the fourth copolymer, it is molecular weight found to be 3456. Next, please. The UV visible spectra of the copolymer. The UV visible spectra of the copolymer, it shows the two characteristics bands in the region 250 to 270, and second band, it is in the region 320 to 340. The more intense band, it is due to the transition of the pi to pi transition. It is due to aromatic ring and the carbonyl group. The less intense band, it is due to transition of the N to pi transition due to oxogram, that is the NH and the OH group. Next, please, madam. This is the IR spectra of the copolymers. The copolymer first, second, third, and fourth, all the four copolymer, it shows the nearly same pattern of the IR spectra band. For the copolymer first, it shows the absorption band at 3325. It is for the phenolic OH group. It shows the band at 1625. It is due to the aromatic carbonyl group. It shows the band at 1482. It is due to the aromatic ring. It shows at band at 2939. It is due to the NH multi. At the 1373, it is due to the CS2 methylene bridge, and band at 2979, it is due to the CS2 and CS3 stretching. Next, please, madam. This is the proton NMR spectra of the copolymer. Again, this is the copolymer first, second, third, and fourth. All the four copolymer, it shows the similar pattern of the NMR spectra. For the copolymer first, the singlet is obtained at 7.1 delta ppm. That is, it is due to the proton of the phenolic OH group. The multiplet at 6.4, it is due to the aromatic proton. That is the triplet at 7.6, it is due to the proton of the NH bridge. The doublet at 2.6, it is due to the proton of the methylene proton of the CS2NH group. And singlet at 3.4, it is due to the methyl proton of the OCS3 group. Next, please, madam. Carbon-13 NMR spectra of the copolymer resin. This is the carbon-13 NMR spectra of the copolymer resin. So this spectra, it gives the information about the carbon skeleton of the copolymer resin. Next, please, madam. This is the scanning electron microscopy of the copolymer. The SIM micrograph of the copolymer resin indicates the presence of transition structures between the crystalline, and the amorphous. Please, madam. Next. Next, please, madam. So, on the basis of this physicochemical and spectral studies, the structure of the this is the structure of the first copolymer. This is the structure of the second copolymer. This is the structure of the third copolymer. Structure of the fourth copolymer. Next, please. The electrical conductivity. Experimental technique. The electrical conductivity of all copolymer resin are measured in the temperature range 313 Kelvin to 428 Kelvin by the LC aricmeter. So first, the preparation of the pellets. The pellets are prepared in a steel die under a pressure of 5 metric tons per centimeter square with the help of the hydraulic press. Next, please, madam. Next, please, madam. By increasing temperature slowly from 330 Kelvin to 428 Kelvin, the resistance were measured. On the basis of this resistance, the resistivity was evaluated by using the formula rho is equal to Ra divided by I, and then on the basis of this resistivity, I have evaluated the conductivity. By using the formula, it is delta is equal to 1 by rho. It is the reciprocal of the resistivity. From this conductivity values, it is found that the conductivity that is goes in increasing as the temperature is increases. Next, please, madam. So electrical conductivity plot of the copolymer resins. So from the Wilson's exponential law, this is the delta is equal to delta. The sigma is equal to sigma 0 exponential minus EA divided by K into 1 by T. So taking log of this equation, so this equation it can be modified as log of sigma is equal to log of sigma 0 plus negative of E suffix A divided by 2.303 K into 1 by T. Now from this equation, the graph is plotted between 1 by T against the log of delta, and for the copolymer first, second, third, and fourth, and the straight line is obtained with the negative slope. From the slope of this line, I have evaluated the activation energy of the electrical conductivity. Next, please, madam. So this is the electrical conductivity data of the copolymers. So for the copolymer, the electrical conductivity, it varies from 2.97 into 10 to the minus 10.
Sorry to interrupt, sir. Sir, 5 minutes are already over.
Okay, thank you, madam. Thank you, madam.
Sir, how many slides are remaining?
Only just this is my last slide.
Okay, okay, sir. Then you can continue, sir.
Yes. So this is the electrical conductivity for the copolymer. It varies from, it is the 2 points. Slide is not clearly visible. The electrical, so from this it is found out that the electrical conductivity, it is increasing from the copolymer first to the copolymer fourth. This is due to as the number of the aromatic ring increases in the structure of the repeat unit of the copolymer, increases the number of the pi electrons, conjugation and delocalization, which may increase the conductivity due to decrease of the forbidden energy gap between the conduction band and the valence band. Next is the conclusion. So from the study, it is found that the copolymer is semiconductor, hence it can be used in the electronic industries for making the semiconducting devices. Next, please, madam. Thank you. Thank you, madam. This is the last slide. Thank you, madam. Thank you, all of you.
Thank you, sir.
Thank you, all of you.
It's a humble request to all the participants to strictly adhere to the presentation timing of 5 minutes only. Our next presenter is Mr. Kavarlal Dabodia, sir.
Hi, good afternoon, everyone. Ma'am, can you please share the presentation?
Yes, sir. I have shared. You can start with your presentation.
Okay, good afternoon, everyone. Myself, Kavarlal Dabodia. I'm a student of MIT Jaipur Chemistry Department, and my topic is novel formulations and evaluations of synergistic effect of neem oils and garlic oil as nano emulsion and to find out its anti-pest and antioxidant properties. Can you next ma'am? So here I will go through the background first. So whenever we are using pesticide, so we are using pesticide in bulk quantity, so it is creating problem to the environment. So there is a need of to develop formulations which can work in very low dose amount and which can give more bioefficacy uh, in the plant. So nano emulsion is one of the way which will help to sort out this issue. So in my abstract, we have taken neem oil and garlic oil, and we have made formulation, nano emulsions formulation using both the botanical products, and then we have find out the stability and the particle size of these combinations. So here in material, I have taken neem oil and garlic oil from the market. And beside this, we require some surfactant to make this nano emulsions. So I have taken octylphenol ethoxylate, castor oil ethoxylate, EOPO-based copolymers, 280 series, and some anionic surfactant from different surfactant supplier companies. Next, please, ma'am. So by the use of some equipments in the lab like stirrers, we have make this nano emulsions by spontaneous emulsification process. In this, what I have done, I have added garlic oil and mix in different ratio garlic oil and neem oil with different surfactants under stirring at 500 rpm for 2 hours, and the different proportions of the surfactant mix was 15:5, then 5, and in that I have gone through 3:12 and 5. So out of these, I have found that GNE6 is the best nano emulsion which we have made in the lab, and the particle size is around 25 micron. So we have measured the particle size using Malvern 300 particle size analyzers, and the particle is in the range of 25 micron. Can you go for the next one, ma'am? This is the different trials which we have taken with this neem oil and garlic oil. So GNE6 sample 6, which is a transparent liquid, which is shown in the pictures. So it is a stable formulations which we have made in the formulation, and we have also studied this formulation under 54 degree for self-life study. In that, we have found there is no degradation and there's no turbidity found in the formulations after 2 weeks of THS studies. And the graph which is showing below, it is showing the particle size of this nano emulsion, which is around 25 micron. Next, ma'am. So from my side, the conclusion, so the nano emulsions which we have made using these two components, it is found stable, and we have studied the anti-fidant and anti-insecticidal and fungicidal property also in the lab, which is under development stage. But in initial result, we have found that it is showing some positive response as a synergistic effect of these both the combinations. This is a small presentations from my side for this novel formulation. Thank you.
Thank you, sir. Thank you so much, sir. Our next presenter is Mrs. Saima Tabassum, ma'am. Yes, ma'am. You can continue, ma'am.
Okay, ma'am. Good evening, everyone. Myself, Saima Tabassum, from School of Chemical Engineering and Physical Science, Lovely Professional University. And today I am here to present the topic entitled as sunlight-driven photocatalytic degradation of chloropyrifos using GC3N4 doped with La2O3 nanocomposite. And I would like to go straight to the introduction part. Ma'am, can you please zoom in? I would like to. Ma'am, please zoom in.
Ma'am, I'm not able to zoom it. Just a minute.
Yeah.
Is it visible now?
Yeah, ma'am. As introduction, nowadays with the development, the pollution is also increasing, and the pesticides in aquatic environment causes a lot of problem. And the use of the photocatalyst for removal of pesticides from pollutant uh, from water and aquatic environment is a green method for degradation. And various advanced aquatic purification techniques employing like photocatalyst mediated photodegradation of toxic organic substances. Graphite carbon nitride is a polymeric material consisting of like carbon, nitrogen, and due to special semiconductor properties of carbon nitride, they shows an unexpected catalytic activities for a variety of reactions, and catalytic activities of GC3 and 4 can be improved by like doping with the transition metals such as the La2O3 and V2O5. Then we will go to the mechanism part. Please, ma'am, zoom in towards this mechanism part. Yeah. This is the catalyst particles, and several processes will occur when the light falls on these catalyst particles. And actually you will be generating the hole in the valency and the electron in the conduction band. And no, this electron and the hole together is called excitation, and this pair of charges is very important that they should not recombine. So if they recombine, they will give out the proton. So the recombination between these two levels will not allow you to carry out the catalytic reaction. And if the electron goes to the surface without meeting the positive charge, then the electron can reduce A to A minus. And so this electron that is important for this catalytic process, and this process can occur like both oxidation as well as the reduction. And the positive hole of the photocatalyst breaks water molecules to form the hydrogen gas and hydroxyl radical, whereas this negative electron reacts with the oxygen molecules to form the this superoxide anion. Then the characterization part. Ma'am, please zoom in towards this characterization part that is below. Yeah. Then the characterization of GC3 and 4, the XRD pattern, diffraction pattern registered for GC3 and 4 showed the dominant diffraction peak at 27.75, and for the trizyme it is 12.99 degree. And this V2O5 doped GC3 and 4 photocatalyst shows enhanced visible light photocatalytic activities for the mineralization of pesticides, and benefiting from like increased surface areas, decreased band gap, and also extended visible light absorption. Then we will go toward this conclusion part, and the research this research work will introduce the novel photocatalytic system and prepared from photometal oxide immobilized with La2O3 with GC3 and 4. And it is cost effective, affordable, and reusable. This photocatalytic materials for complete like mineralization of the pesticides, these chloropyrifos pesticides, to purify the aquatic environment. And thank you so much for paying attention.
Thank you so much, ma'am, for nicely. Your presentation was very nice. Now I request our next presenter, Dr. Pranjit Kumar Bhuyan,
Yes.
sir,
Yes.
to start with his presentation. Sir, I'll share the screen.
Yeah. So I'm Dr. Pranjit Kumar Bhuyan, Department of Chemistry, Kolyabo College, Assam. So my title of the topic is synthesis of polyurethane and the study of their surface morphology. The objective of my presentation is that to synthesize polyurethane macroinverter, both thermal and photochemical, which contain sterically hindered carbon-carbon single bond and carbon-sulfur single bond in the polyurethane backbone. To utilize the thermal macroinverters for the synthesis of polyurethane block polycarbonate and polyurethane block poly-2-hydroxy ethyl methacrylate copolymers. To utilize such macro photoinverters having the carbon sulfur linkage for the synthesis of polyurethane graph polymethyl methacrylate copolymers. And lastly, to study the surface morphology of these polymers by scanning electron microscopy. Next slide, please. Next slide, please. This is the abstract I have already mentioned in the objective. So, I can skip this slide also. The next slide. So polyurethane are a broad class of polymers having only one aspect in common: the presence of urethral linkage. That is NHU in the repeating units. The structure has some resemblance to the polyamides, which is nylon, because of both of them contains UNH group. The segmented polyurethanes are block copolymers of the ABN type, consisting of alternating rigid and flexible segments. They are important subclass of the family of thermoplastic polymers, and due to the different polarity and chemical nature of the segments, they tend to separate into two phases, usually referred to as soft and hard phases. Hard segments usually associated into the hard domains because of the rigidity of the molecules and their intermolecular hydrogen bonding. The soft segments of segmented polyurethanes are usually derived from the linear polyether polyester macrodiols. And the segment polyurethane consists of two phases, and their properties are strongly affected by the degree of phase separation into hard domains and the soft phases. Next slide, please. Next slide. Yes, sir. These macropolyurethanes are used to prepare the block copolymers, the linear polymers, and the graph copolymers. The monomers I have used in my investigation is actinitride, 2-hydroxy ethyl methacrylate, and methyl methacrylate. The surface study plays a major role in the characterization of the polymers materials. At present, scanning electron microscopy offers a possibility of directly viewing the surface morphology of bulk specimens. Okay, next slide, please. The experimental part. So I have synthesized the polyurethane thermal macroinverters based on the MDI. It is a diisocyanate and PPG polypropylene glycol. BD represents butanediol, and TPD is a spherically hindered carbon-carbon single bond, and which is incorporated in the polyurethane backbone so that it can act as thermal macroinverter. The word inverter is the agent which serves the three aspects. It acts as initiator, then transpires and terminator. And this is synthesized by three-polymer method. At first, the MDI PPG were heated first on the nitrogen atmosphere, and then the reaction is followed by the addition of the catalyst, dibutylene diluent. The reaction mixer is again heated for 5 hours, and finally polymers precipitated in water, and it is dried in a vacuum oven for several days. Next slide, please. The synthesis of polyurethane macro photoinitiator. Here, in place of butanediol, so I'm using the DCPD. This is a diethyl carbamato propanediol, which is inserted in the polyurethane backbone so that it retains as a pendant for further polymerization. And with this photoinitiator or inverter, so I'm able to synthesize polyurethane graph polymethyl methacrylate. Next slide, please. Next slide, please. The photopolymerization process are carried out in this Haber multilane photochemical reactor compact LPMP88 at 254 nanometer to synthesize polyurethane graph polymethyl methacrylate. And okay, so next slide, please. Next slide. Okay, the characterization part. So, scaling electron microscopy was performed using LEO 1430 BP electron microscopy operating at 15 kilowatt. The instrument was maximum resolution 3.5 nanometer and maximum magnification 300 kx. To make conducting, the polymer surface was coated with a thin film of gold by a gold spatting technique under the vacuum condition. Here, The use of TPD in the figure 1, the use of TPD as a chain extender dial increase the size of the hard domains structures in comparison to the polyurethane hard domains formed from the MD and butane dial. The structure with the white 1.74 micrometer to 3.45 micrometer. In figure 2, the surface appeared to have a layer of spherulites of varying sizes superimposed on a large squareless spherulites underlying material. The morphology of the polyurethane block polyhema was observed to be different from the polyurethane block polyacrylate. As a result, the growing PMR strain undergoes complex interaction with the soft hydrophilic and hard hydrophobic segments of the polyurethane macroinverter. Such interactions appear to augment the domain formation as well as the coalescence among the spherulites, leading to the observed morphology. So next slide, please. The figure 4. The figure 4, it shows the two-phase morphology. Though the size of the hard segments spherulites are smaller than that was observed in case of the thermal inverter, and based on TPED, there is 1122 tetraphenyl ethane dial as the chain extender. The figure 5 here reveals a different morphology from that of the starting macro photoinverter. The PMA is an amorphous polymer. The nucleation process of the hard segment spherulites in the polyurethane segment was influenced by the growing PMA chain, is polymethyl methacrylate chain. The spherulite formation by the hard segment of pollutants started earlier, but undoubtedly incorporated some of the growing chains of PMMA onto it. Thus, resulted in the deformation of the spherulites, which led to the increased coalescence and resultant continuous morphology. In conclusion, besides revealing the different morphology of the block and gap form from that of the macroinverters or macroinitiators, the scanning electron micrograph has provided a direct proof of successful block and gap co-production process. This indicates that different polymers have different surface morphology. During the course of my investigation, I have mentioned the references, and this is the end of my talk. Thank you. Thank you very much.
Thank you, sir. Our next presenter is Dr. Dharmendra Kumar Satnami, sir. Sir, you can start with your presentation. Dharmendra, sir. Hello. Hello, Dharmendra, sir. Yes, sir, you can start with your presentation. Please unmute yourself. Dharmendra, sir, please unmute yourself. I have shared your PPT. You can start now, sir. Sir, you are not audible. What you can do is you can just leave and then rejoin. Yes, sir, you can start now. Hello. Sir, you are not audible. I'll call upon next participant. Sir, you just try to resolve from your side. We can't hear you. So by the time we'll call the next participant. Our next participant is Mrs. Bhavna Pant. Bhavna ma'am, you can start.
Thank you, ma'am. Good afternoon to all of you. On this virtual conference, here the topic of my oral presentation is property and application of multifunctional material zeolite. Next, please. Next. Zeolites. Some aluminum silicate lose water when heated to form a porous structure with a large surface area. These aluminosilicates are also called zeolite. Zeolite are also known as permutites. Next. The general chemical composition of zeolite is this, where M is the sodium, potassium, lithium, silver, ammonium, H plus, Ca plus 2 or barium plus 2. Characteristics of zeolite, tectosilicates, that means they have the three-dimensional structure built from tetrahedra. Some silicon atom has been replaced by the aluminium. Lowenstein rules impose a limit to the amount of aluminum which may be substituted into the framework. This means that only a half of the silicon atom may be substituted by the aluminum. Open framework structure built from the tetrahedra containing pores and voids. The structure and porosity is periodic. The counter ion are situated in the pores and voids and are usually mobiles. In the void are also these water molecule. One measure of the porosity is the amount of adsorbed water. The water molecule are also present in the pores and voids and may be removed by heating and reabsorbed at lower temperature. Zeolite have a porous structure that can accommodate wide variety of cation like Na+, potassium+, Ca plus 2, magnesium plus 2 and other. These positive ions are rather loosely held and can readily exchange for others in a contact solution. Next. Here are some of the more common mineral zeolites are analcimine, cabezite, cleoptolite, and so on. Next slide. Next is type of zeolite. Generally, there are two types of zeolite. Natural zeolite. Natural zeolites are non-porous. Common example are natrolites, Na2Al2O3.SiO2 and hydrated form. Synthetic zeolite. Synthetic zeolites are porous and get structures. They are prepared by getting heating together china clay, feldspars and soda ash. Such zeolites have high exchange capacity per weight than natural zeolite. Next slide. Zeolite stability. All zeolites are formed in the aqueous solution. The water molecule act as template which are necessary in order to form a porous structure. Most zeolites are formed from the basic solution which favor 4 coordinated aluminum. Zeolites are formed in the low temperature end of the hydrothermal synthesis, about 30 to 300 degrees centigrade. Due to the open structure and high water content, high temperature often give denser material. Next slide. Natural zeolite, deposit and property. They are inorganic, crystalline and aluminosilicate material. Natural aluminosilicate minerals with crystal 3-dimensional structure. Hydrated cation are located inside framework structure and weakly bound with structure. Zeolite have different dimension of pores and channel responsible for their physical and chemical property. They are chemically and thermally stable. 50 different minerals of zeolite are discovered in nature, but Some of them has commercial valuable. Many natural zeolites are synthesized in the laboratory. Difference between natural zeolite minerals is manifested in the content of the hydrated cation, which occupied pores and channel, ratio of the aluminum silicon in the structure, and number of the water molecule. Next. Zeolite are formed from weathering, dilution, and reprecipitation in the fine-grained silica igneous rock or sedimentary deposit derived from them. Zeolite transform to other minerals under weathering, hydrothermal alternation, or metamorphic condition. Advantage of these natural minerals are their large deposit on the earth, easiness of exploitation, and most necessary treatment for the practical application. The most important deposits are in the United States, Mexico, and other countries. Next. Application of the zeolite. Zeolite extremely useful, having an electric range or application which arise due to their distinct properties, like they can hold large molecule and help them to break into smaller pieces. They can selectively absorb ion that fit the cavity of their structure. Their power to interact with water so as to absorb or release ion. Next. Zeolite in the petroleum refining. In the refining industry, zeolite are used for the coarse process like catalytic cracking, fluid catalytic cracking, deep catalytic cracking, shape selective cracking, hydrocracking, catalytic dewaxing, isomerization of the C4 olefin ferrite, methanol to gasoline process. Next. Zeolite in detergent industry. Zeolite type LTA is used in a modern detergent to replace sodium triphosphate to soften water. The world consumption of the zeolite to detergent is approximately 80 lakh ton per year of the zeolite type A. Zeolite in the water treatment. Zeolite have high filtrating ability due to which it performs various functions like ion exchange, absorption, desorption, and modification. Zeolite have a particularly high selectivity for ammonium and can reduce ammonia in wastewater up to 97%. Zeolite can be charged with antibiotic cation of AgCuZn to provide antimicrobial properties. Zeolite filters beds can be used to remove contaminant to purify air. Utilization of the zeolite in adsorption and separation process. Zeolite, due to their innate ability, absorb polar compound, due to which it can act as superb candidate material for the separation and purification of gases. Zeolite with hydrophobic character with a low content of silica are usable for drying gases and liquid. In catalysis, they are extremely useful as catalysts for several organic molecules. The most important are cracking, isomerization, and hydrocarbon synthesis by carbonylation. The reaction can take place within the pores of the zeolite, which allow a great degree of the product control. Next. Origin of proposal. Since I have zeolite are used in the catalysis for the various carbonylation reaction. So since carbonylation reaction is a very useful and sustainable catalytic process to promote one-pot synthesis of the ester, amide, and other heterocyclic compound, starting from the halogenated triplet aromatic hydrocarbon. Catalytic carbonylation is being done by using homogeneous catalyst. The homogeneous catalysts have high molecular catalytic efficiency and a rate at mild condition, and are resistant to a wide range of organic functionality and have excellent reaction product. Since heterogeneous catalysts are usually more durable and easy to work with, and they can be completely removed from a reaction and are used in the subsequent transformation. As a result, both homogeneous and heterogeneous catalysis having their own range of advantage and disadvantage. To overcome these disadvantages and at the same time to gain the benefit of the both homogeneous and heterogeneous catalytic system, a new concept known as the heterogenized homogeneous catalyst system has been developed. Many attempts have been done to combine the benefit of homogeneous and heterogeneous process, such as immobilizing a homogeneous catalyst on a polymer supported or conducting the reaction in a two-phase liquid or liquid system with a water-soluble catalyst. To immobilize catalytic active soluble trans and metal complexes, both inorganic and inorganic soil like zeolites, molecular sieves, silica, etc. are commonly used. Jetsam-5 is a safe selective catalyst which is used in the proposed work. Jetsam-5 supported palladium, rhodium, and ruthenium complexes lead us to establish a fast manipulating, simple, selective, and environment-friendly protocol for the carbonylation of the various compounds. Thank you.
Thank you so
Hello.
much, ma'am.
Hello. Hello.
Yes,
I
yes,
am audible.
yes, sir. Yes, sir.
Thanks, ma'am. Yes.
So you
Uh,
can start now.
yes, ma'am.
Sir,
Hello.
I have presented your PPT. You can start now.
Yes, ma'am. Today's my topic is isoflavone glycoside from Sesbania aculeata pers. Uh, uh, I have isolated one compound, named isoflavone glycosides. You can see there's the NAMNA 5674 tetrahydroxy 8 methoxy isoflavone 5 alpha L remnoperoxyl 7O beta D glycopyranosyl 1,4-H glycopyranoside by various chemical degradations and the spectral analysis. Introduction. Sesbania aculeata belongs to family Leguminaceae. It is commonly known as Dunchi in Hindi. It is distributed throughout in India and plain India and the most tropical countries. Its roots are alexateric, anthelmintic, and diuretics. It's also useful in snake bite and the diseases of the eye. Its seeds are useful in the ringworm and the skin diseases. Next, please. I am coming my result and discussion section. Compound A had the molecular formula C33 at 40O20, having the melting point 293 degrees centigrade to 294 degrees centigrade, and molecular formula 756 FABMS. It gave Mollis test bombs showing the isoflavonal glycosidal nature. The compound also reported to the nature the ferrichloride also test. UV and IR spectra data also shows the nature of the isoflavone. IR spectrum revealed the presence of the 3,446 peaks in the OH groups, and also many peaks also present in the compound shows in the slide. 1H next please. 1H NMR spectrum of the compound shows the various peaks shown in the slides. Also the acid hydrolysis of the compound have been done. Acid hydrolysis of compound with ethanolic 10% H2SO4 yield the egg glycone A1 melting point, having the melting point 280 degrees centigrade to 282 degrees centigrade, having the molecular formula C16H12 to O7 and M plus 316 FABMS, which was identified as the 5674 tetrahydroxy 8 methoxy isoflavone by the comparison of its spectral data with reported data values. And permethylation of the compound A also have been done by the position of the sugar moieties in the compound A were determined by the permethylation, followed by the acid hydrolysis, which yield the methylated egg glycone, identifies the 5,7 dihydroxy 5,6,4 methoxy isoflavone, which confirm that the hydroxy group at the C5 and C7 position of the egg glycone were involved in the glycosidation position. The methylated sugar, which were identified as the 236 triomethyl D galactose and 234O triomethyl D galactose, and third the 23 triomethyl L raminosis. According to the this reference indicate the C1 of the compound L-raminose had linked with the L-raminose linked with to the C5 position of the glycone, and the C third of the D-xylose was attached to the C4 position. of the D-galactose and C double dash of the galactose was attached to the C7 position of the glycone and also shows the interlinkage 1-4 between D-xylose and D-galactose that was further confirmed by the carbon 13 NMR spectral data. Enzymatic hydrolysis of the compound. Compound A with tetra enzyme liberated L-ramanose RF 0.37 and the pyroglycone identifies the 5674 the tetrahydroxy 8 methoxy isoflavin 7 O beta D xylor and pyronosyl 1-4 O beta D galactopyronoside that confirm the presence of the alpha linkage between the L-ramanose and the C5 position of the glycone. Pyroglycone on further hydrolyzed with almond emulsion liberated to D-galactose having the RF 0.18 D-xylose and RF 0.25 suggesting that the presence of the beta linkage between D-xylose and D-galactose as well as D-galactose and the glycone. Spectral analysis of the compound. The spectral study of the compound A have been shown in this slide. Compound A had the molecular melting point 293 degrees centigrade to 295 degrees centigrade and having the molecular formula C33 H14 and O20 756 FABMS found the percentage of the carbon 52.5 and hydrogen 5.3 calculated for the molecular formula C633H40O20 percentage of the carbon 52.3 and hydrogen the 5.2 have been found. The UV spectral data, IR spectral data, NMR and 30C spectral data shown in the slide. Next, please. Next, please. Next, please.
Yes, sir, I'm sharing it. Study of compound A1, right?
Yes, ma'am. The spectral data of compound UV data and IR spectroscopic data and 1HNMR 30C NMR data have been given in this slide. Also, next please. The structure of the compound. Next please. I am audible.
Yes, sir. Compound A structure.
In my side some technical problem because it is raining in.
Okay, sir. Sir, I have shared it. It is structure of compound A.
Yes. Last. You structure of the compound.
Yes, sir. You can continue.
Yes, ma'am. Yes. Study of compound A1 as known as a glycone. It has molecular formula C16H12O7 and having the melting point 280 degrees centigrade to 282 degrees centigrade. Molecular mass 316 first about atomic bombardment molecular mass spectral data. Found the percentage of the carbon and hydrogen, carbon 16.78 and hydrogen 4.1. Calculated value for the aglycone compound A1 having the molecular formula C16H12O7 and percentage of the carbon C60.75 H3.7. UV data IR and 1HNMR 13C data have been given in this slide. Next, please. Next, please. Next,
so
please.
this is acknowledgement slide.
No, no.
No?
It is not.
Okay.
I had not seen. I am not seen either.
Sir, I have shared compound A structure, A glycon, and then the next slide was acid hydrolysis of compound A per methylation of compound A and enzymatic hydrolysis of compound A. And after that, acknowledgement slide is there, sir.
Yes, I have completed a permethylation, enzymatic hydrolysis, and the acid hydrolysis compound. And acknowledgement, I am giving thanks to the head RSI CCDRI Lucknow for the recording various spectral data and elemental analysis. Also grateful to the research guide and the head department of the chemistry, Dr. Harsing Gaur University, Sagar, Madhya Pradesh, India, for providing necessary laboratories facilities. Also thankful to UGC New Delhi awarding for the Rajiv Gandhi National Fellowship during the completion of the research. Thank you.
Thank you so much, sir. Our next participant is Dr. Anija Philip. Anija, ma'am?
Yes, ma'am, I'm here.
Yeah, you can continue.
Can you please share my slide or should I do that?
Yes, ma'am, I have already shared.
I've shared, but it is not coming up.
Can you see that screen, ma'am? I have shared.
I can see somebody else's screen. Some man
Okay,
is
you
there.
have to.
Someone else is no.
Ma'am, Dharmendra Kumar is presenting.
Presenting. Sir is presenting.
Sir is still on the screen.
Sir has to stop.
Connectivity अच्छी नहीं रही.
Dharmendra sir, can you
Dharmendra
please
sir,
stop sharing?
can you please stop sharing? Dharmendra sir, please stop sharing your screen.
If he is not getting, we can remove him because he now presented already. So,
Anija ma'am, now can you see that screen?
I can see, but
synthesis of hydroxy. You have to pin on my name, Savita.
Anija ma'am, when you move cursor to the screen, no, you will find their pop-up like pin.
Pin
you just
option.
have to click that.
Yes. Okay. Got it.
Yes. So there will be no interruption by others.
Yes. Thank you. Okay. Shall I start?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Good afternoon, everybody. I'm Dr. Anija Philip. I'm working as an assistant professor in Hislop College, Nagpur. Today, I'm going to share with you a very interesting transformation of an amino acid into a hydroxy diamino acid. Before we move on to the synthetic details, I would like to take your attention on to the structure of this molecule that you see in front of you. You can see at one end of the molecule, there is an alpha amino acid, and at the other end of the molecule, you have a primary amino group and a secondary hydroxy group adjacent to each other, which is separated by a small carbon chain. So all the molecules that I have synthesized in this project is differing only in the number of carbon atoms here. Rest of the molecule, the amino alcohol moiety and the amino acid moiety remains the same in all the molecules. This is a piece of my PhD work that I did in Dr. Ramesh Ramapanika's lab, Department of Chemistry, IIT Kanpur. So next slide, please. Similar hydroxy diamino acid moieties like 4-hydroxy-ornithine is found in several commercially available antibiotics like bifenomycin and clavulanine, and also in antifungal products like Mansacid B. Here you can see 2,4-diamino 3-hydroxybutanoic acid. Another hydroxydiamino acid moiety, 5-hydroxylysine, is found as a post-translational modification in our body. Ehlers-Danlos syndrome is a genetic disorder in which the body is not able to make the 5-hydroxylysine. I'm sorry, the screen is getting blurred for me. Okay. In which the body is not able to make 5-hydroxylysine, and you can see extra loose skin and muscles. As the age moves or as the age goes, the body's ability to do this post-translation modification of making this 5-hydroxylysine decreases. As a result, you will go from a straight posture into a bent posture, which is very evident in elderly people these days. Next slide, please. Okay. Starting with the synthesis. For the synthesis, you take an carbonyl compound, either a ketone or an aldehyde with an alpha carbon, subject it to hydroxylation by using nitrosobenzene as a source of hydrogen or hydroxyl group or oxygen in the presence of the most celebrated organocatalyst D or L-proline in DMSO at 90 degrees Celsius to give you a hydroxylated product. After the hydroxylation, this carbonyl group can be further reduced by using sodium borohydride or can be subjected to Wittig reaction to form a diol derivative or the Wittig product. It is also possible to subject this carbonyl group into a reductive amination by using dibenzyl amine and sodium triacetoxy borohydride. Next, please. Next, please. Okay, moving on to the project that I have done. This aldehyde derivative that you see here is obtained from glutamic acid. So that is why I said that the amino acid is converted into a hydroxy diamino acid derivative. This aldehyde is derived from glutamic acid, and here you can see that it has an alpha carbon. As previously discussed, this is subject to the hydroxylation by using the corresponding reagents, reductive amination, then followed by the hydrogenolysis, which cleaves both the hydroxy group and also the benzyl group on the amine to form and further Bock protection to form the Bock protected derivative. This Bock protected molecule is further protected on the hydroxy group by using benzyl bromide and sodium hydride to form the benzyl derivative. The acetonide ring is cleaved by using paratoluene sulfonic acid to unmask the amino alcohol moiety. This primary hydroxy group that you see here is oxidized into carboxylic acid under standard tempo conditions to form the hydroxy diamino acids in which the amino group and the hydroxy group is protected. Here also please note that the amino group and the hydroxy group is orthogonally protected. That is, the deprotection for hydroxy group and the amino groups are two different reagent conditions. Next slide, please. If you take D-proline, you get this diastereomer. If you take L-proline, you get this diastereomer. So all the diastereomers are accessible by using this method, and this is the shortest method for the synthesis of this class of molecules. Next, please. Next, please. So, as I have already mentioned, these aldehydes that you can see, these are homologues of the same aldehyde synthesized from aspartic acid and glutamic acid. Depending upon the aldehyde you choose, you can reach up to different isomers or different stereoisomers of the hydroxy diamino acids. This is the ornithine derivative, this is the hydroxylysine derivative, and the first one is the 2,4-diamino 3-hydroxybutanoic acid derivative. Next, please. As I have mentioned earlier, the hydroxy group generated and the amine groups were orthogonally protected in the previous synthetic scheme that I showed you. In this scheme, we have tried to do a non-orthogonal protection wherein all the protecting groups can be cleaved by one reagent. So for doing that, we protected this hydroxy group using mom chloride to get the mom protection. And you all know that the Bock and the mom can be cleaved under acidic conditions. So this is an orthogonal strategy where you can use this molecule for further functionalization. We want to deprotect all your groups together. Next, please. So where do you apply this synthetic strategy? The application of the synthetic strategy is in use of several biochemically important components. For example, benzamide. Benzamide is an important biochemically important molecule which is under different stages of trials in the drug industry. For example, as in neurochemistry as well as in anti-cancer chemistry, structure activity relationship studies for this molecules are going on. Some of them are in phase 3 trials also. So one of the most difficult portion of making this benzamide molecule is this aminocaprolactam ring with the stereoselective R2 that I've labeled here. For this purpose, as we have discussed, a glutamic aldehyde, the aldehyde derived from glutamic acid was taken, subjected to the same transformations of hydroxylation and reductive amination. And this hydroxy group, instead of protecting it, you convert that into the R group that is required here, which is the ester of myristic acid. So esterification of that is done, followed by the same strategy followed by the same strategy of cleaving of this acetonide ring, conversion of this primary hydroxy group into a carboxylic acid, and standard peptide coupling condition by using EDC, HOBT, DiPA, and results in the cyclic amino caprolactam ring of benjamide. Next slide, please. Next slide, please. I would like to conclude that we have developed the most concise methodology for synthesis of this important class of hydroxy diamino acids. We have also did an application studies in the synthesis of amino caprolactam ring of bioactive natural product benjamides. That's all. Thank you for the organizers and to my lab, PhD lab, for this opportunity. Thank you.
Thank you so much, ma'am. You explained in a very lucid manner. Our next presenter is Dr. Sunil Zange. Dr. Sunil. I guess sir is not there. Mr. Shyam Dafre. He is also not there. Next presenter is Mr. Jitendra Pawara. Jitendra Pawara, sir. So I'll stop presenting my screen. You can share your PPT and then you can start with your presentation. Jitendra, sir. I guess there is some technical issue from his side. Let's move on to next participant, Dr. Shibin Chako, sir. Dr. Shibin. Dr. Dilip Chafle, sir.
Yes, ma'am, I am here.
Okay, sir. Sir, I'll share your PPT and then you can start with your presentation.
Okay, ma'am. Am I audible, ma'am?
Yes, sir. Yes, sir.
Okay, shall I start?
Yes, sir.
Okay. So, good evening, all the participants, chairperson of the session, and all dear organizers and their team. I am Dr. Dilip Chafle, Assistant Professor, Department of Chemistry from Taiwade College, Mahadula Koradi, Nagpur. I am going to present on a collaborative work. First, madam. First slide. Ma'am, first slide, please. On the work synthesis, characterization, and application of PBF copolymer. Next, please. And let us see the general background about this polymer study. Ma'am, you are changing fast. Okay. A polymer is a large molecule, that is the macromolecule, composed of repeating structural units typically connected by covalent chemical bonds. Polymers can have different chemical structures, physical properties, mechanical behavior, thermal characteristics, and can be classified in different ways as follows. So polymer on the basis of its origin can be classified as natural and synthetic, while on the basis of components present in a polymer, they are classified as organic and inorganic. So depending upon its thermal characteristics, the polymers are classified as thermoplastic and thermosetting. While depending on physical properties, they are classified as elastomer, plastics, fibers, and liquid resins. Next, ma'am, please. Next, please. So these polymers are also can be classified as inorganic and organic. These organic polymers are of three types: simple, copolymer, and terpolymer. While these copolymers are phenol formaldehyde type of resins and amino formaldehyde resins. These phenol formaldehyde resins are Novalec resin in acid and Rizol resins in base, while amino formaldehyde resins are UF resins and MF resins. Next, please. Next, please. So, experimental and analytical technique. So, synthesis. So, synthesis of copolymer resin has been carried out using above mentioned monomers in different combination in a different molar proportion, like 1:1:3, 2:1:4, and 3:1:5, 4:2:7 at 122 plus minus 2 degrees centigrade for about 5 hours, as mentioned in the following table. And synthesis information of only one combination has been given, and other combinations are similar to it. So this copolymer PBF is being formed by using these three monomer reactant: pyrogalol, birect, and formaldehyde. And the catalyst used is 2 molar HCl, and it is refluxed at a temperature of about 122 degrees centigrade for 5 hours. Next, please. Next, please. So this is the reaction path that I have shown here. So the synthesis of polymer of PBF is carried out by this reaction. Pyrogalol react with formaldehyde and birect in presence of dilute HCl at 120 to 122 degrees centigrade after refluxing about 4 to 5 hours. So this is the structure of PBF polymer that is being resulted. Next. Next, please. So result and discussions. So pyrogalol birect formaldehyde synthesize 4 OTMF resins which are yellow and are soluble in DMF, DMSO, and aqueous potassium hydroxide and sodium hydroxide. On carrying the elemental analysis of this synthesized copolymer, elemental analysis report is being given here. So the percentage of carbon that is observed is 57.62 and found is 57.78. The percentage of hydrogen that is observed is 5.56 and actually calculated is 5.93, and percentage of nitrogen that is observed calculated is 38.15 and 36.29. And from this result of elemental analysis, we have come to the conclusion that the empirical formula of this repeating unit is, ma'am, this figure is blurring, and its empirical formula weight is about 270 about. So next, please. So we have also studied this UV visible spectra, and there are two sharp peaks are being obtained for this copolymer. Resin shows two characteristics bands at 280 to 300 nanometer and 230 to 260 nanometer. So more intense band is obtained at the region 230 to 260 nanometer. So this may be due to pi to pi star transition and due to aromatic phenolic ring and the chromophore, that is the carbonyl group being present there. So less intense band of 230 to 260 nanometer, it may be due to N to pi star transition and due to the oxochrome presence like NH and OH. And this lambda max and excellence max is increases from PBF1. Next. Next, please. This is the FTR IR spectra that we have studied for this synthesized copolymer. Next, please. This is the proton NMR spectra recorded for this copolymer. Next, please. Scanning electroscopy, same study is being carried for this synthesized copolymer. Same analysis has been found to be of great use in understanding the surface features of the materials, imaging to surface features of 10 to 10 to the power 5 times magnification. The white bar at the bottom of the same microscopy represent the scale. The same photograph exhibit irregular long-shaped rectangles and spherulite showing crystalline nature. The corrugations and having shallow pits on the surface show amorphous nature of copolymer, and the same micrographs of OTMF copolymer resins includes the presence of transition structure between crystalline and amorphous. The amorphous nature shows the ion exchange property also. Next, please. So I will conclude this short synthesis in collaboration with Dr. Gurnule. A copolymer resin PBF based on condensation reaction of pyrogalol and biret with formaldehyde in the presence of acid catalyze has been prepared. So with this I conclude. Thanks. I also specially thanks to my mentor Dr. Gurnule sir and my co-worker Dinesh Kamdi. And I also thanks to the organizing committee for giving me this opportunity to present the paper in this session. Ma'am, I have one more presentation. So shall I?
Sir, we are running out of time actually.
Okay.
So
no,
I
have
didn't know that
submitted two abstract. So this is the one and
Okay,
there is
sir.
one more. So shall I present tomorrow?
Okay, sir. Right now I don't. Yeah, you can present tomorrow, sir.
Okay.
Because
Okay. Thank you. Thank you for
thank you
giving
so
this
much, sir.
opportunity. Okay.
Thank you, sir. Our next presenter is Dr. Shibin Chako, sir. Sir will be presenting his PPT.
Am I audible, ma'am?
Yes, sir.
Okay,
So
thank you, ma'am.
I have stopped presentation, so you
Yes,
can
yes,
share
yes.
your screen.
Yes, sure, ma'am. Thank you. Thank you so much. Can you see my screen, ma'am?
Yes, sir.
Okay, good. Good evening, everyone, and thank you so much for accepting my abstract for the international virtual conference. Today, I will be going to talk about. Let me take the pointer. Today, I'll be talking about proline catalyzed one-pot, three-component managed reaction in the synthesis of two alkylated pyrrolidine and piperidine class of alkaloids. My name is Dr. Shibin. I'm from Department of Chemistry, Hislop College, Nagpur. So today I will be presenting my doctoral work, which I have carried out in Indian Institute of Technology, Kanpur, under the guidance of Dr. Ramesh Rama Panikar. Okay, so let's talk about what is meant by two alkylated piperidine and pyrrolidine class of alkaloids. So you can see over here, you know, like I know, like all of us are like organic chemists, or like we at the some point of time we have learned you know, organic chemistry in our life. So I can see like many people are like talking about inorganic chemistry, polymer chemistry, functional materials. So what is mean by pyrrolidine and what is mean by piperidine? So pyrrolidine is a 5-membered organic compounds where there is a nitrogen atom. But in case of piperidine, you know, if you see the cyclohexane, your one of the CH2 methylene group is replaced with a nitrogen atom. That is called piperidine. So now you can see here, it is a 2 alkylated. If you start counting from here, your nitrogen will be 1, and then it is started counting on the right side, then your this will be the second. So this is 2 alkylated piperidine and pyrrolidine class of alkaloids. You can see there are wide varieties of natural product, which is like kind of, you know, 2 alkylated pyrrolidine or piperidine class of compounds. Quinine, you know, quinine is like kind of a historic poison which was used for killing the Socrates. I think we all know the history of quinine. So pelletrine, which is used for killing the worms, you know, when we are having a worms in the you know, in the olden days, people was use pelletrine as a natural product. So allocedridine, cedridine, hygrine is used, you know, anti-convulsants. So there are like all these class of compounds have one or the other medicinal properties, and all of them are isolated from the nature. So that's why it is called natural products. Okay, so our aim was that how can you synthesize this compound in a shortest method? Okay, so that was our aim actually. You can see in the literature there are like kind of 10 steps, 15 steps, because in alkylating on the two position is very challenging, because if you see this position and this position, these both are like same reactivity. So how can you do an alkylation on the pyrrolidine or piperidine ring? Okay, so that was our challenging question. So I was thinking that like kind of can we use proline catalyze one port three component managed reaction? So you may be thinking that proline catalyze one port three component managed reaction. What is mean by one port three component managed reaction? So we have seen many of the people are talking about the reaction. So everything is like kind of one or two reagent you will be using. But here what we have used in one port, we are using four components. You can see that four components which I mentioned with catalyst also. Okay, so ideally it is a three components. Okay, so you will be having an aldehyde, then you will be having an amine, then you will be having an acetone. Okay, how does this reaction proceed? The amine and the aldehyde will react and form the imine. Okay, and the acetone will react with the proline and it will form enamine. So the enamine will come and attack on this shift base or on the imine, and you will be getting the amino ketone. So that will be like 1,3 amino ketone. So my aim is that like, can we put a living group on this aldehyde? So can it possible to undergo cyclization reaction? So that was our question. So the reaction will be very cool. You will be getting two alkylated pyrrolidine or piperidine class of compounds in one step. That's also a three component one port reaction. Okay, so with this, like, we proceeded the reaction, and we are very good that we observed our piperidine class of compounds, two alkylated compound, but the yield was like kind of 3 to 6%, but we didn't observe this open chain structure. That's good. That's a cool result, no? So when you're seeing an organic chemistry, sometimes getting 1% yield is also very difficult. But if you're having a 1% of yield, if you know the reaction mechanism, always the 1% of product can be converted into 99. It's not sure always, but if you know the reaction mechanism and if it is feasible, you should be able to uplift the yield of your chemical reaction. Okay. So with this, I wrote the reaction mechanism, and when I was looking into the reaction mechanism, what is the byproduct is going over here? It is the byproduct is your HBr, and you can see in the reaction mixture we have used only 5 mole percentage of the catalyst. So the amine is very important to participate in the reaction. Suppose the 5% of reaction product form, and then the catalyst is quenched by this HBr, then how this enamine formation will happen? Enamine formation won't happen. So we thought, let's add a base into the reaction medium, So now we are having your aldehyde, amine, or aniline, or then acetone, catalyst, and the base. Then we can see that the yield was improved from 3 to 96%. So what are the base we have tried? We have tried inorganic bases, and we have tried the organic bases. And in the organic bases, we have seen that the yield was like kind of reached 77% in triethylamine. When we use triethylamine as a base, 1%, one equivalent of triethylamine. So what will happen? The byproduct forming HBr, that is quenched by your base, which is added in the reaction mixture. Okay. So now then we have screened the various solvents in the reaction condition. We have tried DMSO, water, and also we have tried the neat reaction. So all the cases we can see that the yield was above 50%. And in case of methanol, alcoholic solvent, we have achieved the yield above 90%. That means we have achieved 99% yield from 3% to 99%. Okay. But the limitation of this reaction, you can see that as I mentioned in the previous condition, all these natural product is having a chiral center. It is not a racemic compound, the chiral center. But unfortunately, we end up having racemic compound. It may be a reason, your HBr or something which is racemizing your chiral center during the transition stage. So the reaction we need to study, or we have to do more theoretical studies, and then how this transition states work. Okay. So in order to see that, we were thinking that is this base which is participating in the reaction racemization, somehow it is quenching the hydrogen bonding. So what we have added this time, we have added 120 mole percentage of the catalyst. That means stoichiometric amount of catalyst. Now you cannot say it's a catalyst, now it is a reagent. So still we end up having the racemic mixture. So we thought something else is happening in this reaction. So we started screening various catalysts. You can see that here we have added various catalysts. We have achieved the 6-membered ring, which is 2-alkylated piperidine as well as 2-alkylated pyrrolidine class of compound. Now what we have done, we screen various catalysts, but still we end up having, racemic mixture. With the racemic mixture in our hand, we thought like, okay, it is better to have a methodology to synthesis, these natural products. This is one of the shortest synthesis which is available in the literature. We see the shortest synthesis of pelletrin. This paper will pop up in the any paper which you search in SciFinder or anywhere. So what we have done, we have took that N-pyrrolidine, N-PMP. Generally, nitrogen can be protected by using PMP protecting group. So the PMP can be cleaved by using steric ammonium nitrate, which is an oxidizing agent, followed by the CBZ protection. You can protect the amine by using ZBZ chloride, which is carbamate. We generally call as a benzoyl carbamate. Now the benzoyl group was hydrogenated by palladium carbon under hydrogen to yield the pelletin. Now you see that if this reaction effectively has done by 3 steps. This is a 3-step synthesis from the starting material. Okay, again, the same intermediate which we have taken from here. You can see that this intermediate took here for the synthesis of cedrin and allocedrin class of compounds. What we have done, we use the sodium borohydrate. Sodium borohydrate can be reduced your ester or your ketone or your aldehyde. So what we have done, we added sodium borohydrate in methanol. The ketone was reduced into the alcohol. So we have got the amino alcohol. Here, if you see that this is the amino ketone 1, 2, 3. This is a 1,3-amino ketone. This is 1,3-amino alcohol. If you see in the literature, you will find a lot of natural product which is having 1,3-amino ketone as well as 1,3-amino alcohol. 1,3-amino alcohol also used to make many organocatalysts. Okay, now let's see how can you synthesize the quinine. Quinine is like in ancient days onwards, people use as a poison. People want to assassinate someone. People was using quinine. So, when I was doing the synthesis of quinine, I was also really panicked because, if it is one drop is fall down into my skin or if it is reaching into my, somehow it will be very dangerous. So how I carried out this reaction, I took this amino ketone and protected as a thioketal. Okay, the thioketal was for the, generally we use ethane dithiol. All of us know that.
Sorry to interrupt you, sir. Sir,
yes.
We are running out of time. So.
Yes, almost there, ma'am.
Yeah.
Okay, so reduce and we got the N-BOC quinine. Okay, with this, I would like to conclude, we have developed a proline catalase 1,4,3 component managed reaction. And also we have discussed the synthesis of 2-alkylated pyrrolidine and piperidine class of compounds. And the same reaction we have explored in the synthesis of quinine, pelletrine, cedridine, and allocedridine class of compounds. With this, I would like to thank my mentor, Dr. Ramesh Ramapanikar, and the Department of Chemistry, IIT Kanpur, Department of Chemistry, Hislop College, and all the organizers, all your effort behind this one during this pandemic to organize such a wonderful event. And thanks for accepting my abstract. And thank you so much.
Thank you so much, sir.
Yes. I'll just show
next present. Yes, sir. Sure.
Yes. Thank you. Thank you.
Next presenter is Mr. Jitendra Pawara, sir. Jitendra, sir.
Yes, ma'am. Hello.
Yes, sir. You can present your screen and start with your presentation.
Okay. Hello, is my screen is visible to you?
Yes, sir.
Okay. Hello, ma'am. Hello.
Yes, sir. Yes, sir. We can see your screen. You can start.
Hello. Good evening to everyone. Myself, Mr. Jitendra M. Pawara, Assistant Professor in the Department of Chemistry, Changu Kanathakur Arts, Commerce and Science College, New Panvel. And the topic of my presentation is synthesis
spectral characterization and biological investigation of some new mixed ligand nickel second complexes. So these are the application of complexes. It is used for the extraction of metal. It has a biological importance. It is also used in medicine, electroplating, and metal industry, and in textile dyeing. So this is my schematic representation for the synthesis of nickel second complexes. So I have synthesized these nickel second complexes by thermal as well as microwave method. So this is the schematic representation, and in microwave method I got the product within 4 to 7 minutes. So this is the schematic representation of that by thermal method and microwave method. So and I compare both the method. So and I found that the microwave method, the reaction time is very less. The reaction can complete within 4 to 7 minutes, and the yield is also high. And in conventional method, the time required for completion of reaction is above 45 minutes, and yield is also less. And these are the complexes that I have synthesized. This NIP, P is my ligand, and alum is a leucine, lysine, tyrosine, aspartic acid, valine, and phenyl alanine. These are the amino acids that I have used, and they are the structure of that complexes. And I have, in characterization, I have performed the UV IR spectra. I had taken the IR spectra of my complex. So this is a IR spectra of my ligand, and the IR spectra of my complex, and the IR spectra of complex is completely different from the ligand. So the major peak is around the 3406. That is due to OS stretching that is absent in the IR spectra of my complex, and assumption has been made that there is a deprotonation of that hydrogen takes place during the formation of the complex, and one important peak around 500, it indicates that the presence of metal ligand bond. It is around 500, and these are the characterization, the molecular weight, decomposition, temperature, pH of my complexes. So these are the empirical formula, molecular weight, and the color of the complex. It is dark blue, faint, dark blue, and blue. And the decomposition temperature is above 300 degrees Celsius, and the pH is around neutral, above 6. Then these are the elemental analysis of my complexes and its molar conductivity and magnetic properties. So my complex, all the complexes are paramagnetic in nature, and this molar conductance value 0.03, it indicates that my complex, all the complexes are non-electrolytic in nature, and this percentage of metal, carbon, hydrogen, nitrogen, it indicates that my complexes is in 1:1:1 ratio. And these are the thermal data of my complexes. So the loss of water molecule takes place in the range of 1007 to 167 or 186. It is in the temperature, and the loss of amino acid and HP takes place in the range of 286 to 501. So these are the found and calculated thermal data. And I have also I have also checked the antimicrobial activity of my complexes, and my complex shows antimicrobial activity. And I have used doxycycline as a standard, and my complex is active against this S. diphtherias, then C. albicans and S. aureus. So these are my conclusion. So I have developed the newer method for the synthesis of some new nickel second complexes, and the microwave assisted method found to be energy efficient, and the complex were obtained in a shorter time, that is 5 to 7 minutes, with a high yield more than 90%, and the synthesized complexes shows higher decomposition temperature, indicating the strong metal ligand bond, and electrical conductance study shows that the complexes are non-electrolytic in nature, and the magnetic studies represent that my complexes are paramagnetic in nature, and the TGDT also support the presence of coordinated water molecule, and and based on these outcomes, the octahedral geometry of the complex has been proposed for the nickel second complexes, and the complexes shows antibacterial activity, and it is active against C. diphtheria and C. albicans and S. aureus as compared with the standard antibacterial agent doxycycline. And This synthesized nickel second complexes shows moderate activity against selected strains of microorganism. Thank you, madam. Thank you very much.
Thank you so much, sir. Sir, can you please stop sharing?
Okay.
So, we are left out with two more participants. They have shared their videos. So, I will be playing those videos for you all. So, the next participant is Mr. Ajay Kumar Gandhi. Sir, please stop presenting. Yeah, thank you, sir.
Yes. May I share my screen now?
Okay, sir.
Hello?
Sir, you can do that. Sure.
Yes. Yes. Is my screen visible?
Yes, sir.
Yes. Just a minute, madam. It's taking some time. Hello, everyone. My screen is visible, ma'am, no? And am I audible too?
Yes, sir. Yes, sir.
Hello, everyone. Here I'm presenting my research work on quantitative structure-activity relationship evaluation of glucagon receptors. They are actually antagonists for the anti-hyperglycemic lead development. Myself, Mr. Ajay Kumar Gandhi, Assistant Professor of Chemistry, Government College of Arts and Science, Aurangabad. Diabetes, as we all know, and we highlighted in this COVID-19 situation, how terrific this situation, which is characterized by elevated glucose level in the body, the diabetes is. There are various different types of diabetes, but type 2 diabetes is very prevalent. And to date, there are about 463 million people who are suffered from the diabetes, and by 2030 it is estimated that this could rise to 578 million. So here only one can understand how difficult it is to tackle with the diabetic situation and its complications. There are various severe complications associated with the diabetes, like cardiovascular discomfort, retinopathy, nephropathy, even black fungus. And in this COVID situation, we understand that this having diabetes is really a terrific situation for COVID infected people that take them to even a deathbed. So it is highlighted here that diabetic or hyperglycemia is something to be treated at earliest. Actually, pathophysiology of diabetes is actually very complex, multi-step, multi-enzyme catalyzed process. There are various different enzymes are involved, hormones are involved. But in the present work, we have targeted one of the promising target, a peptide hormone, glucagon receptor, to treat diabetes and to develop some anti-diabetic leads. Actually, my approach is computer-assisted drug designing, where QSAR, which is thriving branch of this computer-assisted drug designing, is utilized for the optimization of new molecules in silico way. QSAR, actually, those who new to this, QSAR is actually a mathematical correlation between molecular features or bioactivity, which is associated with the molecule, and at the last, or at the fruit, we can say that we are going to apply these QSAR models to develop new molecules, and we can even before their synthesis in the laboratory, we can predict their bioactivity. And these are some molecules which are, first 5 we can see are least active molecules, which already reported in the literature, and the another row, which is consisting of 5 molecules, are most active GCGR antagonist. The purpose to show this slide and molecules is that you can see there is a common scaffold, this 1,2-diazole ring, but a lot many different functional groups are here, many scaffolds are there, and many features are used here. So really very diverse data set is used in the present study. That is the point that I wanted to highlight. What is done in this particular QSAR development is we have selected 44 GCGR antagonists whose bioactivity is reported. And before subjecting those, the steps involved in the QSAR development are, that start molecular structure drawing and their optimization. For drawing, we have used free and open source software like Sketch 12 freeware was used for drawing 2D structures. Then for 3D structures, we have used OpenBabel 2.4.0 version, and we have finally used Tinker for optimization purpose. And once having optimized molecules, we have, with the proper coordinates, subjected them to the molecular descriptor calculation. Descriptor means features, those are expressed in the numbers. So we have the idea about what kind of features are there, in what amount or in what number. So the molecular descriptor calculation was performed using PyDescriptor, another software, and Pardel, one more. I would like to tell this important thing, and I'm very happy to inform that this PyDescriptor developed by Dr. Vijay Masan from Amravati, Vidarbha's Amravati College, and he's co-authoring this particular research. And Pardel is another well-known software which is used for the molecular descriptor calculation. And togetherly they have given about 18,000 plus molecular descriptors. Those encompassing large chemical space. Those are encompassing very large IC50 value range. So truly the data set with the limited number of molecules, but whatever the scaffolds and the number of molecules, the type of molecules selected here are truly having very diverse data set, diverse molecular features in them. As there was a large pool of like 18,000 molecules generated, it was inevitable to have the redundant data pruning to remove the redundant molecular descriptors. So after having the statistical parameters application, this data set of some 18,000 molecular descriptors just reduced to 1145 variables. And these 1145 molecular descriptors then subjected for the molecular QSAR model generation. Here also another software, QSARINS 2.2.4 was used for the development of QSAR model. And here the statistical approach, genetic algorithm, which is blended with the multilinear regression is used for the feature selection or variable selection. This step, I think I should, I must explain this step.
Sir,
that 1145, yes, ma'am.
Sir, 5 minutes are already over, sir.
Sorry. Let me finish in a minute. So this
Yes.
is the way we have. Yes. Then fine. This is the model with which this is the equation. You can clearly see that with this model we can predict the bioactivity of any new chemical entity that in silico proposed before their prior synthesis and biotesting. These are the values like R square, and these statistical parameters are well above the threshold values. So it explains the robustness of the model and applicability of the model. These are certain graphs which it also clear the robustness of the model. This graph explains the applicability domain, and we can see only one molecules thrown out of the applicability, but about 43 molecules were considered. So truly a large chemical space was covered. These are some molecules which are very well predicted or best predicted by our model. Here you can, if you round off these values to some 2 decimal places or 1 decimal place, you can clearly see they are actually identical values. So, but just to clear the thing, we have taken the values to 3 decimal places. So this is also additional proof for the robustness of the model. And these are very easy to incorporate each this bold things are actually molecular descriptors. They have their physical significance and meaning. That meaning can be can be found in the paper itself. When it get published, you will come to know these things. Because we are running out of time, I'm just concluding with this, that these are the molecular descriptor out of which this the second molecular descriptors, CH2CH fragment and this N-butoxy fragment. If you remove out that, the model says that if you remove out these fragments, the compound which will be optimized will have better GCGR antagonism, or we can say better anti-diabetic properties. And okay, so with this, I think I can conclude that this is the model we have proposed, and we hope that this will help chemists to synthesize better antagonists. Thank you so much.
Thank you so much, sir. Our last participant is Jayashree Patil ma'am. She has sent her video, so I will be playing that video. So can you please stop presenting?
Yes, ma'am. Just a minute, ma'am.
Okay.
Thank you so much.
Okay, thank you, sir. So last participant is Jayashree Patil ma'am.
Good morning, all of you. Myself, Jayashree Shailesh Patil, Assistant Professor in JSM College, Alibag. In nature, hardly any substance obtained in pure form. One come across number of unpure substances. Hence, it is necessary to separate the desired constituent before applying analytical methods. My topic is based on the solvent extraction, extractive and spectrophotometric determination and comparative study of some metal ions with N-Bs, orthohydroxyacetophenone, ethylene diamine derivative as an analytical reagent. This is the abstract of my topic, that is the solvent extraction is considered to be one of the best methods of separation. It is based on the transfer of solute from one phase to another phase, which is immiscible with each other. And the main reason for its usefulness among this separation technique is because of its ease, simplicity, speed, wide scope, utilizing apparatus and requirement of only separating funnel, application both trace and micro trace level, concentration of metals which is applicable. Now, introduction of the present study, that is the chemistry has been classified to develop the new techniques for the separation of elements for the compounds. The growing interest of this separation technique has its own importance because of its selectivity, simplicity, time and cost. However, it requires the less solvent, hence becomes environmentally eco-friendly and no sophisticated instruments are required. Hence, the separation procedure involves the operation like the precipitation, distillation, digestion and the coagulation of trace elements. Now the baseline of the present study, that is the student synthesis of the reagent which will form a complex with the metals of interest, determination of pH range and percentage extraction is calculated, determination of interfering metal ions, effect of reagent concentration of the complex, stoichiometry also calculated by Jobs variation method, moles ratio and slope ratio method, and it useful for the study of the precision and accuracy of the method. Using this method, the use of a masking agent to remove the interference of the metal ions, different metal ions, application of the metal for the commercial sample as well as the synthetic sample, determination of suitable solvent for the extraction, and for the extraction this experiment, chloroform is most suitable solvent, determination of effect of time on stability of the complex, to study the effect of salting out agent on the extraction, and to study the Beer-Lambert's range. Now, first of all, I have synthesized one ligand in the laboratory, that is orthohydroxyacetophenone ethylene diamine, which is a cheap base and which is prepared by the use of orthohydroxyacetophenone and ethylene diamine. It is shaked for 15 minutes, and when it pour in water, ice water, the solid appears, which is filter and crystallization of the product. This is the reaction. This is the reaction, and here the stoichiometry is
So I guess she has sent only this much video. So here today's technical session ends. I take this opportunity to thank all the honorable management members, respected dignitaries, guest speakers, and chairperson of the technical session, Principal Dr. Leena Sarkar, for her precious time and giving her valuable inputs to the presenters, which will definitely help in their research journey. I would like to thank all the participants. Hope they must have been elated hereafter to some degree. I wish them best luck for their future endeavors in research. I would like to thank our principal ma'am for her guidance and all my dear colleagues for their support. Thank you so much. So we'll be meeting tomorrow at 9 o'clock. Thank you so much.
Yeah, I would like to congratulate all the
Ma'am, please continue.
Yeah, I would like to congratulate all the participants for the good work they are doing and wonderful presentations. Results for the best presentations will be announced tomorrow during the valedictory function. And my best wishes to all the presenters. Thank you all.